Bonjour à toutes et à tous. On va commencer dans quelques secondes. Je crois qu'il y a encore un petit peu.
Ladies and gentlemen, we'll start in a few minutes. We're waiting for everyone to come into the hall, but it's going to start soon because we've got lots of work ahead of us. Could we start now? Or shall we wait a few more minutes?
On va pouvoir commencer, très bien.
Right, so we're going to be able to start. Ladies and gentlemen, welcome. Good morning. Thank you for welcoming us at the Sorbonne for this morning's colloquium, which is going to bring two worlds together, worlds that don't get the opportunity to be together much, scientists and public decision makers. So we are here for the restitution of a collective scientific expertise on the effect of wind turbines at sea and biodiversity, ephemer, and so on. So this is at sea wind turbines. They've got many being made nowadays, and they're being rolled out on a maritime areas, but this is already being set up in ecosystems that are under pressure. And the question is easy to ask but difficult to decide on. What do we know exactly on the effect of these wind turbine parks on maritime life? So this morning we'll be here to answer this question. We're not going to base ourselves on opinion. We will base ourselves on the available scientific knowledge. So a quick presentation of a schedule. So we'll have a presentation of the expertise by the researchers who did the research, and then there'll be some discussions with you all in a room. We'll have about 30 minutes to listen to your questions, and finally a round table to put this knowledge in perspective, both on the side of action and decision making. Before we move on, I will give the floor to Alain Scholl, Vice Director General of Science in the CNRS. Mr. Scholl, you have the floor. Thank you. I think that this was pretty much, well, very comprehensive. That's quite a summary, isn't it? Can you hear me? It says good morning, everyone. I will give a few names nonetheless. Firstly, those who commissioned this expertise, Madame Hermine Dureau, who's in charge of renewable energy at the GGSE, Mr. Vincent Slipper, Sub-Director of a protection of littoral and maritime ecosystem at the DGANM, and Mr. Mathieu Renavo, who's in charge of maritime affairs at the DG AMPA. Thank you for giving us the opportunity to do this work. I would like to thank the politicians, MPs and senators who are present here today with us, because it shows how important today's meeting is, and Mr. Moutnier, President Director of Ifremer, with whom we did this work. He's going to close today's meeting. I'm opening it, but I'm not going to talk about wind turbines at sea. I'll talk about the processes we use to carry out a scientific expertise to show how important and interesting these expertise, that's so the CNRS and Ifremer, have separate missions for scientific expertise. So for the CNRS, we have the cell for public studies and 2 missions carried out this joint expertise. So basically, ESCos bring together all the scientific knowledge, international knowledge on the topic. So basically, you could have ESCos on not uninteresting subjects, but we focus on topics that are societal issues, and you need to have a scientific approach on them. That means that the deliverables will be scientific, and you can't deny them, and you can use them as a foundation for your decision making. That's why they're so important. The results lead to a compromise from the establishment based on 4 major principles. Competency. So we have 25 researchers from 13 research establishments who worked on this for 2.5 years. Independence from work that is totally independent from external influence. We make sure there is little pressure on the researchers. Impartiality. These expertise are based on scientific publications. They're not a series of scientific opinions. It's more than 5,100 publications, peer-validated publications, which were re-peer-rated, and more than 400 were analyzed. And this methodology used meets the most demanding international standards. Everyone who took part in this mission can answer any questions. It was quite a methodology. And 4th pillar, transparency. We publish the results, but also the method that led to these results. This will be accessible shortly, and this meeting today, this colloquium, is part of this transparency. So this is quite an exceptional colloquium. It'll be exceptional every time we give you results. Basically, we're taking stock on a situation. It's a scientific overview of the impact of wind turbines at sea on maritime biodiversity. We have some information. There's the full report, 1,000 pages, more or less. It's not finalized yet. It'll be finalized shortly. A summary that's about 100 pages long, and the shorter summary, about 10 pages long. The objective of a study is not to make recommendations. We're not here to tell politicians what they need to do. We're here to tell you the level of scientific knowledge. And the political decision makers are going to take this as an element to make decisions with other elements that are at play in this decision-making process. And that's what's so important. The results we have here today will still be relevant in 2-3 years' time, and that is why they're so relevant nowadays, when discussions around energy choices and their consequences are often very polarized. And independent expertise allows us to make the difference between what is certain and what isn't certain. Some conclusions allow us to see where we don't have enough research underway, and where it would be good to see if there's something to be done, and that's a result of his job. Directors questioning the impact of human activity on the living world is giving ourselves a tool to better understand the transformations that can lead and better understand the effects of the measures taken to alleviate them. On behalf of our two organizations, the CNRS and IFREMER, I would like to thank you for having commissioned this expertise. And I would also like to thank the 25 scientists who worked in this expertise, who expended energy and time on this work. It was long-haul work, and I hope that the result is worthy of their work. They did this at the same time as their research work, their teaching, and expertise of this size is a huge level of work. And I would also like to thank the steering team, the two people who steered this, Cédric Bachet and Nathalie Niki, the project manager, Eugénie Cazot, Sheen Heighton, who was in charge of the systematic review of the literature. And lastly, I would like to thank Valérie Lallemand-Breitenbach, the director of the MPES and her team, and her counterpart in IFREMER, Olivier Lepierre, and their teams. Thank you for your presence here. And I wish you a very fruitful day of work, which I hope will be as good as you expected. And I hope it will enlighten you on this very important matter. Thank you very much for your attention. Now, as you reminded us, this expertise was the result of a commission from the ministry that's in charge of energy and energy transition and the seas. And we'll see why this expertise was asked for, in what context and with what demands. And I would like to welcome the representatives of the three ministry, Hermine Durand, Subdirector of the Electric System and Renewable Energy, the DG EC, Energy and Climate, Vincent, Subdirector of Protection and Restoration of Littoral and Maritime Ecosystems, in the Direction of Water and Biodiversity, DG Éoliennes, and Mathieu Renaudot. You have 20 minutes. Good morning, everyone. My name is Hermine Durand. I work at the Energy Ministry. I'm in charge of the electric system and renewable energy. Mr. Director General and Mr. CEO, this is a pleasure for me to be here today in this beautiful, symbolic lecture hall for the restitution of this research. We are faced with a major channel, climate change. If we want to fight climate change, we need to leave fossil fuels. To leave fossil fuels, we need to electrify our usage by adopting decarbonated energy, nuclear and renewable. And maritime wind is going to play a crucial role here. We have the objective of developing 80 gigawatts of wind turbines and 40 gigawatts of wind turbines, and seen this was stated in 2022 by our president in the Belfort system. We can't have an environmental program if we don't look at the impacts. This was after an arbitration that was won in the middle of the creation of a national observatory for wind and sea. And the minister, Mr. Castex, gave us an amount of 50 million euros to work on wind turbines and sea and its impact on biodiversity. We structured this observatory with 3 missions, which is recouping the existing knowledge and analyzing it. This seemed like it was quite obvious to do, but it wasn't obvious. It's the first thing to do, and that's why we had a first REX study. But we really decided to focus on the scientific expertise, collective scientific expertise. This was the keystone of this observatory mission on regrouping knowledge. Then we launched new studies on maritime environment because we thought foreign migrations, for example, we think there's not enough knowledge, Let's go for it. Let's launch a program in the Mediterranean, in the Manche Atlantique region, because we know we'll need this knowledge. But for the future, we will also need the results of this study to prioritize our work, to prioritize funding, and to make sure that we do things usefully for the development of wind at sea. This is why we asked CNRS and IFREMER to carry out this expertise. It dates back to 2023, so we had 2.5 years' work on this ESCo. It's a true pleasure for me to be here today to take part in the restitution of this work. And I really would like to congratulate and thank all the researchers, these 25 men and women who contributed and steered this study. It was remarkable work. It's actually something unforeseen, a huge amount of work with these analysis of 400 publications. And now we have this state-of-the-art knowledge of the impact of wind turbines at sea. So what are we going to do as commissioners of a study? Well, we're going to publish this study because this is a document that needs to become a reference for future study. We're going to use this for our public policies and also to continue working on wind turbines at sea to orient for future studies and try and target the place where we are short on knowledge. And of course, we will continue with the work of the observatory to pursue the effects of the first wind parks at sea, because they are being commissioned one after the other, aren't they, and opening one after the other. And this is going to allow us to develop this sector, which is crucial to fight climate change and to electrify our economy. We launched an electrification plan a few weeks ago, actually, and it's going to allow us to continue protecting and preserving maritime biodiversity. Thank you for your attention. Thank you, Hermine. I would also like to thank the people who did this study. I'd like to thank them for the quality of their work on wind at sea and biodiversity. My honor is to represent the ministry in charge of the sea and fishing and the Direction General of Fishing and Aquaculture. And I would like to stress 3 points. Firstly, this study is a contribution to our policy of maritime planification, and it will be precious, crucial. In other words, it meets 2 of the 4 priorities of our national strategy for the sea and the littoral, i.e. the document that defines a policy, the maritime policy, decarbonation through the development of wind at sea and the protection of biodiversity, and the other 2 others are sustainable development of maritime activities and the well-being of the populations. So this study will allow us to enlighten interactions between wind at sea and biodiversity, and it contributes to reaching this objective of maritime planification. And on the one hand, keeping a close eye on a cohabitation between wind at sea and the environment, and make sure that our usages are compatible with a good biological state of the maritime environment. So this is a study that was 2 years. There was a major public debate, the debate and the consultations that came afterwards, and this led to the maritime planification at both plans for wind development, positive points for biodiversity, and the conditioning of maritime activities and activities within future wind parks, including with maritime fishing activities. If maritime conditions allow it, this maritime planification process is a continuous process based on dialogue and consultation, and they must be supported by scientific input. This is why this report is a precious document to enlighten debates that will come. This is why we all desire that this expertise's results be known in the observatories for wind at sea and all interested actors and decision makers. So this is how we'll be able to make the most of a study to orient the future programs for acquisition of knowledge throughout the cycle on wind and projects on wind. We will work on this in the European Pact on the Oceans and also the Observatory on the Oceans, the Ocean High. I would like to conclude my speech by saying this is a major deliverable, a major project, and it fully meets its vocation to support public policies, and it is an instance for cooperation and dialogue between administration, scientists, and different actors, whom we are all here to represent today. This is why our ministry is still mobilized to work in consultation for a harmonious development of wind at sea. Thank you for your attention. I'm looking forward to this colloquium, which will be very interesting. I'm now going to give my floor to my colleague from the DEB, Vincent Slipper, in charge of water and biodiversity and the protection of maritime environments and areas. I'm going to be very brief. My two colleagues said pretty much everything. I would like to thank the two main actors of this ESCo, the CNRS and the Ifremer, for their excellent work and the importance of their work, the extent.
ESCo is the starting point. It's an accomplishment because we have worked on the project for 2.5 years, more than 411 scientific articles as mentioned, but science is progress. We're continuously hearing about improved and increased science, and science is going fast in marine research. The margin for progress is considerable. We're still discovering new species today at a very rapid pace, more so than for terrestrial species, and so there is tremendous opportunity for progress. Again, ESCo is the starting point. It is the point of reference as we move forward and investigate the interactions between wind farms and marine environments. Marine environments are not very healthy, are not in very good condition. We have a monitoring program every 6 years based on a framework agreement, and results show that in spite of the lack of knowledge, variables are not pointing into the right direction. Variables such as temperature, for example. We have talked a lot about temperatures recently, terrestrial temperatures, but also water temperatures, and we know that sea water temperature is increasing, induced by global climate change. ESCo has been able to show effects that have been fairly well documented, obstacles for birds, the so-called reef effect as well, with effects that vary from one ecosystem to another, and ESCo has been, and that's the robust side of ESCo, they've been able to show that all the research that was analyzed covers sandy seabeds in the Atlantic, and this is something we're probably going to come back to a bit later. And that covers a lot of marine environments, but in the Mediterranean we have other ecosystems, and the same thing's true for the Atlantic. So transposition is not that simple when we seek to anticipate what consequences this may have on French marine environments. There is tremendous room for progress. So the limitations of ESCo have been developed, have been explained, and scientific research will have to overcome those limits to have a much better understanding of things. I won't be much longer, and I'm going to give the floor again to our moderator. Thank you very much. Thank you all three. And thanks for setting the stage. Let's now move on to the scientific response. The role of this expertise is to bring together and generate a discussion around the available scientific knowledge and data, and to explain the process. I'm going to call the two pilots, Nathalie Nikhil, who works with CNRS, and Cédric Bacher, who is a researcher at Ifremer. Thank you very much, and I would like to thank the audience. This is a very prestigious venue, very impressive. I would like to thank all the scientists who have participated, and I would like to thank as well all those of you who supported us. I would like to thank Eugénie Cazot, who has been our good genie. Without her, nothing would have happened. Eugénie, thank you so much in the name of all the scientists. So, we have a number of key messages to communicate in this presentation. So it is based on the most comprehensive set of scientific research and data, which is based on systematic review of international scientific literature. We're going to explain how we've done this systematic scientific review. It is based on a systematic review of 10 pressures, types of pressure, exerted by offshore wind farms. And we have identified several mitigation measures, which we're also going to share with you this morning. And we're going to close with some of the most significant knowledge gaps and how they could or should be addressed. So we had several deliverables. Today, this morning is one of the deliverables, which is this conference. So we have a detailed scientific report, which is very comprehensive and includes all our research, all the statistics as well on the scientific data which was analyzed, which will be published later this fall. So just to set the stage, what is an offshore wind farm? Because that's what is covered by the scope. So we're going to we analyzed all the systems, wind farm systems, power production systems, as well as the surrounding of a wind farm, which connects them to the seabed, so the fastening and anchoring systems, the related electrical infrastructures, both onshore and offshore facilities, and logistics. So we have different existing technologies. We have fixed and floating technologies. We've also looked at the entire life cycle of wind farms. They are based on 4 phases of development. Prospection, which is before actually developing a wind farm. Prospection is what allows people to decide whether we should go or not go. Then there is the construction. The life cycle of a wind farm is 25 to 30 years, so that's the phase of operation, and eventually the decommissioning. When we talk about biodiversity, we don't just count species, but we talk about all variabilities of the living world, which includes diversity within a given species, such as this nudibranch, which is one example. It's 2 pictures of the same species, inter-species variability or inter-ecosystem variability. And we don't only characterize the structure, but also we developed their function. We investigated the function of organisms and populations within the ecosystem. So this very multifaceted diversity was really at the core of our research. We decided to work on pressures. So the definition of pressure is a mechanism by which a wind farm modifies a natural environment, which generates measurable effects. Understanding the pressures allowed us to cover all wind farms and analyze different technologies, environments, configurations. Another benefit, and this was really important for us, was to actually focus on mitigation factors, to mitigate those pressures. Mitigation was observed on biodiversity in a very multifaceted way. So we looked at the essential variables of biodiversity, EBVs, which is a common framework for describing biodiversity responses beyond the concept of species. This framework is used by international organizations and bodies such as IPBES, for example. Another important choice we made was the neutral characterization of results. We talk about effects rather than impacts. We decided deliberately to not say that an effect was either positive or negative. Positive or negative can sometimes seem obvious, and yet there are many situations where that is not the case. For example, if a crab decides to settle at the foot of a windmill, is that positive or negative? Well, that's something we decided to not consider. So we identified 10 different pressures. We're going to mention them very briefly here, and you will then have those different pressures presented in a more detailed way in the 10 chapters. So we're starting from the wind turbine and then moving away from it. So the wind turbine itself is a physical barrier to movement, and depending on the substrate, the different types of substrate, hard or sand, and this is what creates this reef effect, moving away. There are 2 modifications, changes in the water column. This is what we call pelagic habitats, and at the seabed we are talking about benthic habitats. Moving on to the next pressures, there is a range of pressures generated by emissions, starting with sound or noise emissions propagated around the turbine, which various impacts depending on the distance. There are chemical emissions coming from the actual structure of the wind turbine, which disseminate in the ecosystem. And there are then other forms of energy input, such as electromagnetic fields, as well as heat or artificial light, which is also produced. It's a source of energy, especially at the top of wind turbines. Last but not least, there are additional pressures. These are a bit further away from the turbine. The introduction of non-native species, for example, They can propagate from one ecosystem to another, from one turbine to another, changes pressure in the maritime landscape, and the modification of activities and fishing activities, which can also have an impact on biodiversity. So this is mainly fishing. And that's it for the presentation. Thank you very much. Thank you very much. Before we go into the results, let's talk about the process that was used to analyze the scientific literature. We have Sean Heighton and Mathieu Autier who are going to present. Over to you, gentlemen. So we used a systematic review methodology for literature review. It is a structured methodology which is aimed to identify, select, analyze, and summarize scientific knowledge. It is based on international standards and guarantees a number of things, such as transparency and traceability of the method, rigor and reproducibility of the results, comprehensive conclusions, as well as a reduced selection and interpretation biases by experts. As part of this ESCo, RSL compiled a structured corpus of relevant scientific publications to address the question raised. So this corpus enabled the creation of a database to produce two important things. The first one is a general knowledge map, which Mathieu is going to present in a moment, as well as detailed analyses by pressure, which will be presented later by my colleagues. I'm going to present here the method which was used to build this corpus and produce the analysis, which was applied across all chapters of the experts' report. So what is a detailed RSL? A detailed RSL starts with the appointment, but the question, the initial question, which really was the thread, the guideline. And so we do bibliographic research with a question, which gives us by bibliographic findings. We ended up with approximately 4,500 articles, so we made a selection of those articles, and with the selection of articles, we only kept the ones that were really very closely connected to the subject, and this narrowed it down to about 411 articles, which is the final corpus. We then proceeded with a coding to extract key information from each article and to put it in a database. And with that database, we then conducted some analysis, graphics, statistics, and that generated a knowledge map. We also sorted articles based on specific pressures or by pressure. Each chapter has its own pressure. One article on chemical pressure, another article on sound emissions, for example, and coding and analysis is done for each specific pressure. What is really important with this process is that we have checked and monitored the consistency of the data to avoid biases or errors. So we started with a knowledge mapping. It's an Excel spreadsheet which contains 167 columns. Each column represents a specific piece of information coming from different articles, such as biological groups, pressures, effects, the general context of the study, or the wind farm. Examples are what pressure does the article study, or what biological group is analyzed. Is it fish, for example? Or in which sea and for how long, for example? 6 months. What's really important with this coding and mapping system is that one article can cover several studies, several emissions. The emissions on fish, for example, addressed sound emissions and their impact on mammals, but there are differences between fish and marine mammals. So to better characterize those, we have to separate them into two distinct studies. Let's now look at what science says. Thank you. Well, what does science say? Following this very rigorous selection of the corpus, it shows that the 411 articles generated 518 studies. So, as we said before, we're accumulating knowledge based on with an increase of the number of studies that were published. Most studies document or an average duration of 5 to 6 years, and the life cycle of a wind farm is such that we need the anticipated life cycle is between 25 and 30 years. So, looking at the map, the geographies, we have color codes here. The darker colors reflect the intensity of research, the number of studies. We can see that a lot of the research is coming from the northern hemisphere, especially North America and Europe. And within Europe, we are seeing that the main area where most of the research is conducted is the North Sea, because this is where most of the knowledge is concentrated, the knowledge from the corpus, and covering approximately 100 wind farms. Looking at the distribution of the studies, we can see that there is a significant imbalance across technologies. There is very little research, about 3%, which are actually covering floating wind farms, which what Cédric mentioned earlier. And so most look at the other technologies, which is foundations that are onto the seabed. And 70% of the research focuses on prospection, construction, and operation. Very little on the decommissioning phase. And this is not really a surprise, because the life cycle of a wind farm is about 30 years, and the corpus covers a period between 1998 and 2024, which roughly represents 25 years of knowledge. Looking now at the breakdown of studies, what we're seeing is that the corpus focuses primarily on for 2/3 on the park as a whole and its foundations. And there are very few studies on peripheral components, such as traffic, maintenance vessels, or cables, for example. Note that 70% of studies are conducted in the field. The remaining 40% are more experimental. So it's actually 60-40. We focused on combinations of both pressure and biological groups. As Natalie said, we looked at a few combinations and with a real focus on some combinations of biological pressures. 3 combinations represent about 40% of the studies. The first one is structures as obstacles for birds. That's the majority of the studies in the corpus. The second most studied subject is noises, sound emissions in the marine environment and their impact on marine mammals, and the introduction of new structures with potentially new habitats for some species, the so-called artificial reef effect, and crossed with the benthic macroinvertebrates, such as lobsters, for example, or bivalves. Looking at the absence of some combinations as well, some groups are very studied, such as marine mammals. Other species or other parameters are much less examined. For example, the the reef effect and their impact on mammals. Another originality of ESCo was to look at the essential biodiversity variables, EBVs. 60% of the research focuses on species and populations. Fewer studies look at other EBVs such as genetics, ecosystem communities, and we were able to document 4 times more effects detected than their absences of effects. Those results have to be taken with caution because they very much depend on the context, and it is the context we are going to investigate now, as Sean said, by analyzing the pressures chapter by chapter.
Merci beaucoup.
Thank you very much to the two of you. So now let's get into the thick of the results with the experts who, as we said, decided to present the state of knowledge, pressure, by following a progression in space. So I would now like to invite Sophie de Grissac, maritime bird researcher, and Aurore Raoult, who's a researcher in maritime biology at Caen University. So you have the floor. Good morning. Thank you. Wind turbines will shortly be the size of the Eiffel Tower, so you can imagine they could be an obstacle in the maritime landscape. An obstacle leaves us 2 options. Either you avoid it, either you go into it. When you talk about avoiding, when you avoid all of the wind turbine pike, it's macro avoidance, and a corollary is what we call the barrier effect. This is what I'll be saying in the future. Mechanically speaking, when you avoid an obstacle, when you avoid the wind turbine pike, you are not less likely to collide with it. Conversely, if some species are attracted by turbines, the likelihood to collide is going to go up. What species are we talking about? In our corpus that had 127 studies, most of them studied maritime birds. That's no surprise. That's what they specialize in. Some studied land birds, migratory birds, that are going to go in a maritime environment on the road. And then there are a few studies on bats and maritime mammals, which are generally seen from the perspective of disturbances due to noise. This is an obstacle, but our colleagues focus on this. So these effects of this collision and barrier effect, well, collision is quite simple. Here's a diagram on the screen, death. And as for the barrier effect, it's far more indirect. If a wind park is on an area where maritime birds usually fish, or that's frequented by maritime birds, if they avoid it, it's going to lead them to relocate on other areas. It's a wind park that's on a route of other birds. If it's between the nest of a maritime bird and a fishing area, they'll have to avoid it every day. And it can be a wind park that's installed on the usual route of migratory birds, of course. So collisions can be modulated by micro-avoidance, the ability of an individual or species to avoid the blade or the turbine. What are the effects of a barrier effect? If we avoid them and relocate, a relocated individual who's relocated on a suboptimal habitat can have problems in acquiring energy. It's going to limit their ability to acquire more energy. And if you avoid it, they need to provide extra energy to cover those kilometers they need to cover. So this is the state of knowledge, what the science says. This relation, which is a compromise between collision risk and the barrier effect, because one's going to reduce the other, and species will be broken down in a continuum dependent on their sensitivity, one effect or the other. They are just in various places, but there'll be several factors of variability. Some intrinsical factors, species, flights, speed, reproduction state, and external factors, weather conditions, and also the characteristic of wind parks, the size, surface, and the height of a rotor. Just a few examples here from this literary review. So the bottom left, puffins, they always fly just over the water edge, so they're not very sensitive to collisions. We don't know much about the barrier effect, but they don't have much risk of being hit by the rotors. It's weaker. Gulls now. Gulls regularly fly at the level of the rotors, unlike puffins. On top of that, they're attracted by wind turbines, and not only is this level of attraction and the flight height going to vary depending on the species, and also within species it varies depending on the individuals. You'll go in wind parks more or less and have more or less of a risk of going into collision. As for migratory passerines, dependent on the studies, they'll fly above these wind turbines. It's not the case for all species, but when they go back down to the coast, they're more at risk of colliding. So the collision risk is going to depend on the distance of a park from the coast, and this collision risk is worsened by, in the case of bad visibility, i.e. rain, fog, because migratory birds fly at night. Some loons avoid the parks, but if they go inside the parks, they fly at the height of a rotor. They're more at risk when they are fishing, because their attention's focused on the bottom. That's for northern gannets. And finally, loons are a brilliant example of robust scientific consensus, because all the studies show they avoid diving. They're pushed away by the farms from a few kilometers away to up to 16 kilometers, depend on the studies. So this effect of a wind park goes beyond the surface. So the impact of a wind park, 80 square kilometers, is going to become an void, and a relocation of up to 1,600 kilometers, depending on the bird species. And then you'll say this, a few kilometers deviation when you're a bird that covers thousands of kilometers for its migration is not much. You're right. Some studies do show that. Nonetheless, this is where we have this idea of cumulative effect. What if a bird sees a succession of wind parks on their journey? It's not the same, is it? And that'll be the case for relocated studies. The effect of a park in itself will be limited, but if there's an accumulation of parks in a smaller area like the channel, it's going to lead to quite a loss of available habitats. This accumulation of parks and effects is going to have an effect on a population, potentially. Very few studies study these cumulative effects, but we do have a study on northern gannets. It shows there's not that much a significant effect. But if we, if in 2018 there was a study that shows a population decline if the area of wind farm increases tenfold, or if they encroach on 5% of referred fishing areas. So, in conclusion, these effects are antagonistic, synergetic, cascading, and depend on the variables, so they are complex. This makes them specific to the species, to the sites, and the timescales. So what this work highlighted was what we don't know. On many sites, on many species, species that aren't studied, much like bats, the complexity of the variations and everything we can't study. This specificity limits the generalizability of the studies and requires the collection of a significant amount of empirical data that are going to feed into models. Because if we can't measure every collision on every turbine, we'll need models. This on-site data is going to allow us to improve the robustness of the studies and the scope of the risk models. If you underestimate the percentage of night flights of a species by a few percent, you can modify the result of a model tenfold. You can go from 100 to 1,000 collisions per year. It's not the same, is it? This model that's consolidated by empirical models is going to transpose the studies done on the scale of a population, taking into account the accumulation effects and parks. So we need long-term studies with some hindsight. These upstream studies give the best result, and let's not forget the impacts on a species. I mostly mentioned the negative effects, but species like gulls are attracted by these turbines. It's because they find opportunities, even if it's just a resting space, and also food, thanks to the reef effect. And that's what Aurore, my colleague, is going to tell us about right now. Good morning. Beyond this physical barrier for birds and bats, at sea wind turbines are going to generate pressures on the maritime ecosystem, because this introduction of turbines at sea is going to also bring along the introduction of artificial structures. And these artificial structures will generate new habitats which will be quickly colonized by new species. This is what we call the reef effect, and this is what I'm going to talk about. To qualify this reef effect, we based ourselves on 58 articles and 110 studies. That was our corpus. Out of this corpus, we had 3 key findings. Firstly, bentos, which is the benthic compartment, the organizations that live close to the sea bottom or in the sediment. So you can see them on the screen, mussels, crabs, and so on. We saw a sustainable increase of biomass and in-depth modification of local communities with many mussels and amphipods. To illustrate this reef effect that's associated to a mast of wind turbine, here's a picture of a mast in the North Sea, which is almost 100% colonized by mussels. This is what we call mytilization. Why mytilization? Because mussels in Latin are Mytilus edilus. So they can represent up to 80% of a total biomass on a turbine. If this reef effect is present in all the seas where we have wind turbines, the exact effect will depend on the site. Here is the reef effect of a wind turbine park in the channel. Here we have many amphipods, barnacles and sponge. We also have an effect on fish. There's a local increase of the abundance of some fish species, like cods. We will have larger individuals within the park than on the outside. Here is an aggregate of Thorndon Bank. So we see many more fishes in a gravitory study with more than 20 kinds of this fish, which represent more than 20.7 tons of biomass, 2.7 tons of biomass. the restructuring of trophic networks. What is a trophic chain? Well, it's basically the food chain, and it's very complex in the oceans. We have measures for many types of fish. We'll have a reorientation at the level of this food chain or trophic chain. This trophic network is very present in the top predators. So, acquired knowledge, solid knowledge was acquired on this reef effect. There are many knowledge gaps. For a few long-term studies, this limits our understanding of how the artificial reef effects evolves over the years. We have many unanswered questions on species reproduction. Do some species reproduce within the parks, but also on the exchanges between different population interactions? And there's also the effects on ecosystem, the carbon and nitrogen cycles, which are still poorly understood. Very few studies on the floating wind turbines. We don't have much on that, particularly when it comes to the floats, cables, and the mooring lines. And also the future of these communities after the decommissioning. We don't know the long-term ecological consequences of removal of the structures, so what you need to bear in mind is that this building of wind parks is going to lead to new substrates. They'll play the role of an artificial reef, create new habitats, and the consequence will be an increase of the abundance of some species of fish and benthic organisms, and an increase of the level of a trophic network. Thank you very much for your attention. Thank you very much for this presentation. Now we are going to keep working in a maritime environment. We're going to talk about the habitats now. I now have Alexei Sanchez, who is at Université Côte d'Opale, and Arthur Capet at the University of Sciences Naturelles and Université Libre de Bruxelles. So we're going to give you the floor. Thank you. Good morning. Now, I'm going to talk about the modification of pelagic habitats. There's two direct pressures generated by wind parks on pelagic habitats. Firstly, direct pressures linked to the physical presence of these parks at sea. The foundations of turbines are colonized by filtering organisms, and this leads to the reef effects that can attract fish, pelagic fish. This pressure, both the reef effect and a colonization effect, can modify material flows locally and also for habitats. The effect of these pressures were detailed just now by my colleague. A second category of pressures regroups the processes and the modifications which are linked to the physical properties of seawater and the maritime environment. Wind parks modify turbulence, stratification, vertical mix. To the left, you can see the complexity of all these columns around the foundations of a turbine. To the right, this is a very long line, sinuous. In every crest and hollow, you can find small water flows. So, possible effects of this turbulence. There are four effects of pressure identified. They're rated A to D. There's firstly the dispersion of phytoplankton and zooplankton by the turbulence. B, local increase in phytoplankton, nutrient input thanks to the turbulence. from the bottom to the surface, and there's this vertical flow of material. And then there's also this turbid plume that modifies photosynthesis by phytoplankton. A local reduction in production can be the result of a biofiltration that's carried out by the filtering organisms that colonize the wind turbine. And supports. What does science say? The analysis of 40 articles corresponding to 40 studies shows that very few effects were truly documented. Only the nutrient and the increase in phytoplankton, this was observed several times in a wind park in the North Sea. Biofiltration has been modeled. This was the result of studies in parks in the North Sea, which led to this modeling, but there was no study on the effect of turbulence on a dispersion of phyto and zooplankton. This is not documented. And for limitation of lightening, i.e. the turbid plume's effects on phytoplankton, has not been demonstrated. Because the results of the studies are contradictory. In conclusion, the demonstrated changes in physical parameters, stratification, mixing upwelling was clearly showed in the literature. The result is uncertain, but this modification depends very much on local conditions that are observed on site. The quantification is very difficult to measure. Moreover, the limited number of study sites and of studies, mostly in the North Sea, restricts the generalizability of the results. We found no study that describes the effects of turbulence on phytoplankton. As for the needs, it's basically acquiring long observation series, better taking into account phenomenon in the spatial and temporal diversity, better taking into account the spatial scale of this phenomenon. And it's also necessary to carry out studies in the French context in order to limit the dependence of our results on studies carried out in the North Sea. And finally, we recommend the use of new systems, observation standards, geostationary satellites, mobile systems, and so on and so forth. Thank you for your attention.
Hello. So we looked at modification of benthic habitats. This includes all organisms living in the sediment, at the surface of the sediment, or for which the sediments are a significant component of their habitat. As far as pressures are concerned, there is a lot of the construction work which involves manipulation or the movement of sediments or material. We have all the disturbance of the pelagic environment with new forms of turbulence, an alteration of the primary production of the water column, which can have an impact on the balance of the deposition of organic or mineral matter and the suspension or resuspension. And the so-called reef effect, which was already introduced a few chapters ago, which can also generate the input of organic matter organisms can die and sink to the seabed. That's so much for the pressures. So we looked at 28 articles in total, 161 studies, and we made a distinction in those studies according to the objectives. Some looked at the biotops. Some studies specifically looked at species, very targeted species, when others were investigating benthic communities, so in a broad sense. So what are the major findings? The major findings show there is an increase in organic matter in sediments around the turbine. This is a dominant result, and an alteration of the substrate. So we have the size of grains. We have a layer which shows small gravel or thick sand. As far as studies that investigated specific species, some looked at their abundance and biomass. We're looking at various studies investigating very different types of organisms, urchins, crabs. So we classified them, and see if there was a decline, stability, or an increase of biomass, or a mixed effect, which means a non-quantified expression, which could be a displacement in space, for example. So very different types of studies. And when you look at them globally, again, 54 studies, 31 studies show stability. Additional studies or research didn't look at abundance or biomass, but that looked at some measurable characteristics of individuals, what we call traits. Things such as their diet, their morphology, physiology, reproduction. So when we look at all the research and 41 studies, once again, 28 are showing stability, which means there is no major impact or significant impact found. The third category is the one that looked at the benthic communities as a whole. As far as they looked at biomass and abundance, 16 in 25 studies showed there was an increase of biomass. And in terms of diversity, looking at the number of species represented within a community, most were talking about a mixed effect or stability. Only 2 studies in 25 showed a drop in species or species-related indices. Let me just remind you of 3 important characteristics of the benthic environment. First of all, when it comes to the water column, we can have a lot of heterogeneity in space. It is an environment which changes very slowly with some inertia. Sediment is where matter settles. So there is a lot of inertia, and it is an environment which is very difficult to access. Most studies were conducted very locally, so with a very local scope within 100 meters of a turbine. Very few studies actually had covered a long period of time. Most were 5 years, less than 5 years, and also because they're difficult to access, so very few samples, which means very limited statistical power. Remaining questions are: what are the significant effects at a larger scale, a wind farm scale, and at even beyond? And time-wise, what is the temporal scale of the effects? Have we had enough information? Thank you. Thank you, gentlemen. Let's now continue and look at the emissions. And we will see that emissions can reach quite far sometimes. We have Christine Kepla, who works at the University of Caen, Normandy, Jean-Luc Jung, and Camille Vogel, who does research at Ifremer. Thank you, and good morning. I'm going to tell you about the emissions of chemical substances. We looked at two types of molecules primarily, the organic origin ones and metals associated to entropic activity. The data we analyzed are coming from 7 articles that were included in the corpus. All show that most studies are focused on the emissions of metals, especially metals coming from the degradation of anodes that are used in the protection against corrosion of the metal, the submarine metal section of wind turbines, as well as iodine, which can be present in the motors. We were expecting also to see organic matters, paint, for example, and on the blades or the mast. There is only one study which looked at oils that could be coming from turbine motors. As far as the measured effects, we found an increased level of concentration levels of metals in the vicinity of the structures, what we call bioaccumulation, which in the biological tissues of species that were exposed, for example, mussels or oysters, bivalves, mollusks, as Aurore described earlier. They represent, they are the ones that are stuck to the mast. Physiological alterations, long-term alterations, but not causing any changing the mortality, and changes in communities of benthic microorganisms in the sediments in the vicinity of the foundations. Those effects are all very contrasted. There were very local studies right in the very near vicinity of the masts. And they were combined with responses from individuals rather than multiple species or multiple individuals within a given species. So the bottom line is that analyzing this data allowed us to show the massive knowledge gaps in emissions for existing wind farms. And most studies are coming from exposure of living organisms in labs in controlled environments. There are only 2 studies which reported measured effects locally in a natural environment. This was in the Sea of China, but very few in France and in Europe. Those studies looked primarily at the 9 studies of the 7 articles which were shortlisted on metals, 8 in 9. And of course, there is very little on other emissions, other organic matters that are emitted. We have very few biological species which were studies, 6 in total. Some are mentioned here on this slide, and but only for individuals, but not overall populations or species communities living in the vicinity of wind farms. Thank you. Over to Jean-Luc. Good morning. I'm going to now tell you about noise emissions or sound emissions. First of all, just a few reminders. Sound is fundamental in marine environments, and sound propagates much faster and much further than in air. We talk about acoustic marine landscapes with 3 components: biophony, which is all the sounds that are emitted; geophony, which is all the natural sounds that are not coming from biophony, rainfall, waves; and anthropophony, which is sound emitted by humans. So this would include, in this case, wind turbines. Another fundamental piece of information is that animals use sounds to communicate, navigate, orient themselves, detect prey, and so on. So sound has multiple functions for animals. Offshore wind turbines generate sound at every stage of their life cycle: exploration, construction, operation, and decommissioning. Another important information is that sounds generated by wind turbines tend to overlap with the frequency ranges used by many marine animals. This is true for mammals, fish, cephalopods, crustaceans, and so on. Sounds are not homogeneous during their life cycle. Sound can be transient, high intensity. That's generally the case during the construction phase. Continuous when it's during the operation. Noise emitted during the decommissioning has yet to be determined. All this is very hypothetical because of the limited number of decommissionings. And the construction phase is the one that generates the most significant noise levels, especially with the pile driving. So what knowledge do we have? We have a corpus, again, of articles with a growing body of literature since the mid-2000s. We've shortlisted 74 articles representing 137 studies, several studies by article, of course. The corpus is structurally unbalanced for different reasons, geographically. With a real focus on the North Sea, it is unbalanced because of the phases. Most research covered construction and pile driving, 60% that is, and it is unbalanced from a taxonomic standpoint because it is widely dominated by marine mammals, and within them mainly the common porpoise. And note that in this there are no in situ studies at all published in France. So what are the effects? We've detected biological effects in the majority of studies. So they show that there are detectable effects. 85% of studies show those effects on exposed organisms. Most of them are temporary, such as behavioral disturbances, such as disappearing, avoidance, disruption of communication. There's an impact. There are physiological responses or effects, auditory. Permanent effects are rare, less than 6%. And in terms of distance varies greatly depending on the organisms we look at. For mammals, some studies show effects covering several dozens of tens of kilometers, where for other species we're talking about several hundreds, up to a few hundred meters. And mitigation of effect with the bubble curtain, or by reducing sound and their effect on by using soft starts, for example. Those measures can be efficient, and they will be covered in a dedicated presentation immediately after this one, or maybe the following one. Knowledge gaps. Back to this general diagram you saw earlier, which shows the different phases of the life cycle of a wind farm. And note that there is a very wide disparity in studies depending on the life stages of wind turbines. Pile driving has been extensively investigated and studied, which might lead to believe that other aspects have no impact. Some biological models focus research on specific areas, which makes it difficult to generalize findings across species, even for very well-studied groups. Note a lack of integrative studies on sound and acoustics combining multiple biological models. A long time scale and a baseline state of the acoustic landscape to measure induced changes. And last but not least, one idea which is not that obvious, and this is something that we've only known for recently, that sound is fundamental for marine animals, and we have a lot of fundamental knowledge that has to be further developed to better understand those principles. A lot of this is work in progress. Thank you. Hello, I'm going to tell you now about other forms of energy and electromagnetic fields, artificial light, as well as heat. Those pressures are observed mainly during the operational phase, and they vary very greatly. Light is perceived by birds over several kilometers during the night and therefore has an impact on them. Electromagnetic fields are emitted in the sediments, and they can therefore be felt a few meters away from windmills and impact the vertebrates and fish living nearby. Heat is also emitted by up to a few decimeters around the cable, and it may affect benthic invertebrates who are living in the sediment. So we have looked at a total of 21 articles, 125 studies. One case study is one experimental protocol which crosses one species with a level of pressure and an indicator for that given species. So 125 studies, 102 are for electromagnetic fields, that's the majority, 23 on light, nothing on heat. I'm going to focus on electromagnetic fields. What's interesting is that the vast majority was conducted in labs. More than 80% of the corpus, the documented corpus, is in a lab. And you should also keep in mind that there are no effects of the electromagnetic impact on survival. The impact on survival. We have 71% of the facts are non-significant for electromagnetic fields. On the less than 30%, there is an effect on egg and larva, on the spatial distribution on individuals, which means how they are positioned and where they position, on their physical condition, as well as on their swimming behavior and activity. As far as identified significant effects, you should keep in mind that electromagnetic field values are generally much higher than what was measured with sometimes 10 times to 100 times higher than those measured in situ. In real conditions, what we're seeing is that for some species, there has been an impact on stingrays, for example, and they are very sensitive. It has an impact on their activity and behavior, and lobsters, which is commercially an important species because their distribution is different when there is an electromagnetic field. This being said, in the research we had, the authors of the research identify difficulties in connecting effects to the vital functions of individuals. So, if we come back to knowledge gaps, I'd like to come back to heat, light, and then we'll briefly talk about electromagnetic fields again. There is no information about heat whatsoever in the corpus of research we looked at whatsoever. Very little information on artificial light. The study we did have were on experimental systems that cannot really be transposed. We had single masts. So we're still wondering what would be the influence on light on birds. And there was only one article on birds and on bats, sorry. So as far as electromagnetic fields are concerned, we still need to understand the mechanisms of perception of magnetic fields. Humans don't feel electromagnetic fields, but we don't know how animals and species feel them and respond. and studies are mainly for individuals, but not really for general populations over a long period of time, the ones that are fixated to the cables or migrating species that will come across cables several times during their life cycles. Last but not least, our corpus also shows there is a significant lack of knowledge for other categories of marine biodiversity, especially mammals and reptiles, that is. Thank you.
Thank you. Thank you to you three. Now we're going to move on to the last group of pressures. We'll see what happens when there are multiple POCs that transform entire ecosystems. So we have Sakina Dorothée Ataya, who's at Sorbonne University, Catherine Bohemard at the ESSS, and Philippe L'Enfant, who's from Perpignan University. You can sit down if you wish. Thank you. The first pressure I will talk about is a pressure at the maritime landscape scale. We'll move away from wind turbines and local parks and see what goes on at the larger spatial space. The first effect is exchange between populations that are established and new arrivals. What we call connectivity, when you include new artificial habitats, you expect that the number of individuals exchanged between distant populations vary. With the accumulation of these wind turbine structures, which are artificial, you could expect that individuals disperse and colonize these artificial structures in a progressive way. This is what we call a step-by-step progression. And the third effect is overflow. So that is basically exchanges between these populations from the artificial habitats and natural environment. Spillback effect. This can have an effect on the spillover and abundance and geographic breakdown as well. And the last expected effect is the modification of migratory routes. What are the effects documented at the level of the landscape for what biological targets? Well, our corpus allowed us to identify 62 articles who offered 105 studies. And there are very diverse effects, a variety of effects that are observed for diversity of biological groups. So the main biological groups documented are birds and fish. The first effect at the level of landscape is a diversification of abundance. The number of effects per population can go up, down, or remain unchanged. However, the drops in abundance were seen in birds and maritime mammals, as you can, like the ones you can see on the screen. There was an increase in abundance in fish like soles and some types of crabs. The second documented effect is the distribution area of these species. We can see an increase of its distribution areas or a lack of change. Nonetheless, the shrinking of distribution area was seen in birds, in the stern, with occasional changes in migration routes, and increase in distribution areas in benthic and pelagic invertebrates, like the ones you can see on the screen. Moreover, with some species, like the blue crab, you can see different effects seen. In the blue crab, there was an increase of abundance and distribution areas, but there was also a modification of connectivity patterns, exchanges of individual between distant populations, and the presence of step-by-step diversion, progressive in other words, going from an artificial structure to the next, and spillover effects when you have individuals that go in the natural environments and reciprocate. In the example of a blue crab, the landscape effects were seen over 30 kilometers. So These effects are both multiple and they concern different types of biological targets. So, where are we short of knowledge? Well, where there's a strong, significant taxonomic bias, birds, 35% of studies, and fish, 19% of studies, and there was very little quantification in terms of connectivities and distance. The distance was only mentioned in some studies on mammals, birds, and invertebrates. And there's some knowledge gaps, which are true for other chapters of his collective expertise. Because our studies are mostly interested in sandy substrates and two other knowledge gaps which are important, not taking into account the interactions between wind parks and maritime areas with status of protection and management, even though the surface of the parks is 77% covered by maritime areas with a protection status. There was also no taking into account of a grey infrastructure, the effects due to the accumulation of artificial habitats, ports, offshore structures, and so forth. So those are the main knowledge gaps for our pressure at the level of landscape. This can be observed for indigenous species and non-indigenous species. And now I will give the floor to my colleague, Catherine, who's going to tell us about these non-native species. Thank you. So non-native species are species which are present outside of initial distribution areas and they're a result of human activity, be it on purpose or not. So we expect all sorts of effects, modification in the diversity, density, and biomass of local species and communities, changes in population dynamics, like in species distribution, changes in ecological interactions, be it competition, predation, or parasitism, and changes in habitats and ecosystems, and the indirect effects on human activities, availability of commercial species, which is important for fishermen. So, the state of knowledge, we analyzed a corpus to identify effects that are documented by the scientific literature. Our corpus was very slender. It was made up of 4 articles that represented 4 studies. It was quite surprising, actually. These are studies that were published between 2009 and 2022, mostly located in the Northeast Atlantic. These are operational wind farms. And they were documented with in situ sampling, modeling approaches, or underwater video observation. Among these biological groups that are studied, it goes from the species, invertebrate marine insects, to macrobenthic communities. One of the specificities of this corpus is that it works on a specific zone in terms of wind farms between the high tide and the low tide levels. So intertidal sea, basically. What is the knowledge? What is the state of knowledge? And what can we have as conclusion? The first point, which is consistent with the effects documented in the reef effects in the maritime landscape, is that these artificial structures are supports for the installation and also for the dispersion of non-native species. They facilitate the local establishment of non-native species. So this is true for the Japanese midge and another species which we call the Japanese caporal. There's also modifications of the makeup of the communities, and the meaning of these effects is not established clearly. We don't know if it favors local communities, or on the contrary, which harms them. So the effects are poorly documented, as in 4 studies, and their existence and non-existence cannot be ruled out. So knowledge gaps, very limited number of studies, a major constraint on the assessment of potential effects. Knowledge is heavily concentrated in the intertidal zone. Deeper areas remain very poorly documented for effect on the maritime landscape related to the dispersion of the non-native species, including the connectivity between wind farms and artificial habitats, is not addressed. The genetic and health aspects, pathogens and parasites, are absent from studies directly related to wind farms. So the results should be interpreted with caution, taking into account the cumulative role of artificial marine infrastructures, the dispersal relay, and the presence of all factors for the introduction of non-native species. Thank you for your attention. Good morning, ladies and gentlemen. We're going to conclude this description of pressure by talking about mankind. When you talk about wind farms, you talk about human activities. And what's often presented in human activities is fishing. Fishing can be regulated either by a reduction or elimination of some activities. And the expected result is a restoration of natural effect. You talk about the reserve effect because you were drawing parallels with studies carried out on protected maritime areas. What do we expect? An increase of biomass, an increase of abundance, and an increase of the average size of individuals, so better reproduction, and some effects on a specific variety. So on a diagram, what you can see is the reconstitution of benthic communities that are sensitive to disturbances. The main activity on these substrates is trawl fishing, and also you expect to see a recovery of fish species populations, a reorganization of food webs, as was presented on the reef effect, and some ecologic functions. I was talking about reproductors, but also nursery areas. So if you draw this parallel with reserves, you've got the spillover effects, i.e. fish. I may talk about fish, but it can be other species, of course. Fish are going to benefit adjacent fisheries. And in the context of RSL, unfortunately, we only have 13 publications, 22 studies. On these publications, we can see the macrofauna, especially benthic macroinvertebrates. There's an increase in the lack of pressure from fishing. This is the case in Belgium and in the UK. And if you now look at the species that are fished, you can see that for some species there's significant effects in the level of abundance. When you reopen fishing on lobsters and other kinds of fish, there'll be an increase in the population. So the species recovered well, but dependent on the species and the age of a park, the results aren't necessarily always significant, but what does come out is that the average size is a nice indicator of its reserve effect. The drop of the pressure of fish, there's less time for species and individuals to grow. And if you look at fish, the effect is mixed. There's some increases, there's some decreases, or no clear signal, or even a clear decrease. The exact opposite effect. This is because these are very highly mobile species that range goes far beyond these marine parks. Sometimes they're inside, sometimes they're outside. And another important point is the age of these wind farms. When we analyze these protected maritime areas, to detect this kind of signal, you need to wait 5 to 10 years. And these are farms which are still quite recent, less than 10 years old. Trophically, this has been something that's been studied in the models as a restructuring, a reorganizing of a trophic network, and we can see a spillover effect when there's partial closing of a fishing on the local fisheries. If you go back on the ground, this spillover effect has not clearly been observed. But what is interesting is that these activities are maintained in these park areas, but there's no reorganization or tightening around the limits of the parks. As you can see in protected maritime areas, the best indicator of the good working of a protected maritime area is that the fishermen will focus around them, they'll concentrate around them. And this isn't the case yet because we don't have enough history. And one last example, the European place, there was acoustic telemetry. We do, because I do the same, actually. And we see one thing, that these place will use wind parks for foraging, and they'll leave the farms for spawning because the reproduction areas aren't around there. Okay, knowledge gaps and uncertainties, the underrepresentation of many biological groups. Pelagic fish aren't studied, top predators aren't studied. This has a big impact on others. The rarity of integrated ecosystem scale approaches, the reserve effect is multifactorial. It's complex. So you need a global vision, both of the trophic networks and the interactions between the different species. And we talk a lot about wind parks and protected maritime and marine protected areas. Offshore wind farms are not substitutes for marine protected areas, but they can, in how they work, be complementary. It's a global management strategy for the marine space. Thank you to the three of you. Thank you for your attention. So this closes this overview of knowledge, pressure by pressure, but once we've described the effects, what can we do to mitigate them? And once more, scientific literature can be helpful. So we will now hear to Catherine Bohemard and Sylvain Pioche, who is at University of Montpellier, Paul Valéry. Please join us, Madame Bohemard and Mr. Pioche. Good morning again. This work was carried out with Romane Boileau. She's not here today, unfortunately. What we tried to do in this chapter is basically give us a state of knowledge on the responses offered by developers, what we call mitigation measures. Measures that are meant to avoid, reduce, or offset all the effects that are categorized in these wind parks. So basically, our corpus was quite large, 100 articles, 150 studies were analyzed. We categorized mitigation measures into three types: technical, management, and planification measures. Technical is technological systems that can be set up to avoid, reduce, or offset the effects. Management are managing the usage within these wind parks or near them. That will give us the same mechanics. And planning is what measures you can take before setting up for wind farms to locate the parks in a place that minimize the effects as far as is possible. So what we see, after studying 100 articles and 115 studies, is that there are two major biological groups that suffer: maritime mammals because of noise emissions, and birds and structures as physical barriers. The other biological groups are very rarely documented. So we're touching on the environmental impact study. So these other measures that are set up in most countries on this relationship between humanity and the environment. So this introduction is very important because the objective of a social contract is to make installations managing whilst minimizing the impact on nature. Since the 2016 law in France, we want to avoid net biodiversity loss. This leads to a sequence in three parts. Firstly, avoidance, eliminate potential impact at the source, eliminating pressure, reduce the intensity, and what cannot be reduced or avoided needs to be compensated to reduce the negative impacts. So, thanks to compensation, we measured 73 avoid, reduce, compensate measures, mostly in the reduction of these pressures, and a small proportion on compensation, and very few avoidance measures. The reasons that are presented in more detail in a chapter of a study. So we took 3 examples. So firstly, an important point that has to do with maritime planning, the ability to install parks or wind parks dependent on the nature of a sea bottom to avoid negative pressure. The second point is reduction, as was explained by my colleagues. Basically stopping the blades turning at some seasons or times of the day to avoid collision risk. And the illustration with this very impressive picture, so wind and bubble curtains to avoid the sound effect when you're driving the piles or other technological points. And lastly, last compensation measure, choosing some materials dependent on these materials' ability to welcome native species that could have been harmed when the parks were built. Here is an illustration from Ter Osted for some oysters species.
So let's now take a look at the knowledge gap. This scientific field of mitigation is still quite new and incomplete. Most studies are concentrated in Northern Europe with a focus on birds and mammals while neglecting other biological groups, communities, and ecosystems as a whole. We have an underrepresentation of the submerged parts of the infrastructure, lack of empirical validation of the proposed measures. Only 34% have been tested in situ, when all the others are just proposed measures, either concepts or just mere proposals. The strategies that are documented are based on technical adjustments, mainly the reduce part, when levers upstream of projects to avoid or downstream to compensate are largely unexplored in scientific literature. Approaches that integrate both ecological and social aspects are very rare. They could be beneficial, however, and a last observation is that new ideas such as eco design or nature positive or nature inclusive design, are looking beyond compensation. They're emerging concepts, yet they have to be more finely documented when it comes to their implementation, efficiency, and potential indirect effects. Well, thank you both. So this is it. We are going to move on to the final stretch of this first session. What are the conclusions? What are the things that are well documented? What are the uncertainties? And what does research need moving forward? We have Cédric and Nathalie again. And after the conclusion, we're going to give you the floor for our Q&A session. So be prepared. Make sure you have your questions ready. We will take approximately 30 minutes. Over to you. So before we conclude, we would like to briefly recap some of the knowledge gaps we identified as we investigated pressures. There is one chapter in the report which is focuses on knowledge gaps. We've called it cross-cutting knowledge gaps because they are shared by many pressures. So the first observation is that a lot of pressures are under-documented. So we've listed the most undocumented pressures and items: chemical emissions, the introduction of artificial light, changes to pelagic habitats, connectivity at the marine landscape scale, and consequences of the introduction of non-native species. So these are very under-investigated. They're identified but under-studied. The second set of gaps is taxonomic biases, which is a term we have used several times this morning. So taxonomic biases shows that there are some species are well known, marine mammals or birds, some commercial species as well, but unfortunately at the detriment of other groups. The barrier effect: no studies on underwater species, changes in pelagic habitats, and the reef effect. Very little research on phytoplankton and zooplankton response to disruptions. And as far as marine landscapes are concerned, how can we go beyond protected or commercial species? Very little information at broader scales, covering entire populations, communities, or ecosystems, and marine landscapes. For example, chemical emissions, where study was done at an individual level, but we have no idea whatsoever on more global impacts. We have a consistent lack of data, long-term data, to distinguish the effects of wind farms from other human activities and the long-term effects of natural variability. We need to distinguish, identify specifically the impact of mills, sound, for example, where with the integration along the entire life cycle of a wind farm, and there is also a lack of cumulative effects, and a lack of multi-pressure studies to characterize cumulative effects between pressures. For example, we were able to observe the reserve effect, the artificial reef effect, changes in pelagic and benthic habitats. All these things are very tightly connected, and it is important to see what the cumulative effects are. And it is important to go beyond the borders or the limits of wind farms and see how they interact with the gray infrastructure in a cumulative way. And in closing on knowledge gaps, there are three other important points, which is the limited applicability to certain types of ecosystems and wind turbines. We gave you many examples this morning, but for example, the alteration of benthic habitats. Habitats are not the same in the North Sea as in the Mediterranean. Therefore, it is difficult to transpose results. They could very well be the same, but we don't know it for a fact. and it greatly depends on habitats. Well, we have very little data on the Mediterranean Sea, and floating, and then the distinction between floating wind turbines and the others. Then, another important knowledge gap is, and this may not have been very clear in the presentation, but it's something which we've really very well documented, is that there is variability in statistical methods and protocols for measuring effects, which somewhat limits the comparability of results. We couldn't do any meta-analyses on the corpus, which could have allowed us to extract a lot more information. For example, on electric magnetic fields, we found we needed a lot more research for in situ. And last but not least, then there is the question of decommissioning. In the life cycle of wind turbines, decommissioning is the end of the life of a turbine, and there is very, very little research today for very obvious reasons. There are only 3 cases of decommissionings that have been documented today in Sweden, Denmark, and in England, simply because wind farms are still being operated today, and that's the reason why. So we have very limited data, only 3 cases, only 3 studies. Then there is the value of analogs. We should not wait for the decommissioning to actually look at potential impacts or effects by using analogs. These are comparable pressures than the ones that were studied to identify what could happen after the decommissioning. So, what are the key takeaways we would like to convey today? First of all, we hope we were able to prove that we have a very comprehensive knowledge map, and the chapters of the detailed report, everything you've heard today is presented in chapters with total between 50 and 150 pages per chapter, so it's very, very comprehensive. We've also analyzed 10 pressures. We understand their mechanisms, their pathways of effect. 3 have been very well documented, the others less so. So what we do know is that there is likely long-term changes in biodiversity at a large scale, and in those transformations, the transformations that we've identified suggest that those transformations are and will be long-term. So again, the detailed report to address the knowledge gaps. There are 5 strategies to address those knowledge gaps with relevant stakeholders. First of all, with our integrated approach, we should not work in silos, but really look at all taxonomic groups. We need standardized multi-scale approaches to better characterize the cumulative effects. Second, we need more in situ testing, and we need to scientifically evaluate the effectiveness of mitigation measures. The entire scientific community should be mobilized to address that point. We need long-term multi-wind farm monitoring. We need easier access to data, and wind farms. We need to make sure the data can be used by others. And last but not least, we need to harmonize the protocols and share best practices, both in terms of follow-up and long-term research. That is it. Thank you so much for your attention. I would like to thank a lot of people. We did at the beginning. I'd like to do it again. I would like to thank Eugénie, Sean, and the other experts, and 22 experts who have spent endless hours working on this. I would like to thank our 4 interns as well. Romane Boileau was already mentioned, but I would like to also thank Gaëtan, Alice, and Othman who are 4 interns and who were very precious, very supportive, and our 3 documentalists, Miga, Patricia, and Isabel Close. Thank you so much. Thank you. Please have a seat. We have microphones. We're now going to take approximately 30 minutes for the Q&A. Go ahead, take a seat. So please keep your questions short. I think we have a question right here. Yes, sir. Hello, Eric Santori. Preserving the identity of the sea in Brittany is really important. I would like to thank you for the research and the comprehensiveness. The first question I have is, are you going to make your slides available to the general public? And the second question, my second question is the following. There is a new tender called Éoliennes, which I think is legality is questionable. It's 10 gigawatts, which is massive. Half of it is floating, and that makes a huge difference. And I would like to insist on the fact that floating wind farms use anchors, 6 20-ton anchors by platform. That's standard. And they will actually disrupt the seabed. In South and North Brittany, it has an impact on the corals. These are they're sensitive seabeds, they're rocky seabeds. What happens to the artificial reef? What happens to the corals, cold sea corals? It will take centuries to rebuild them if they're damaged. Those floating systems will also use cables with a risk of capturing or hampering some species. They're very high power wind turbines. We're talking about more than 300 meters high, 20 meters in width, which means more infrasound. This is something which has been demonstrated by some Danish study. The bigger and the higher the power, the more infrasound is generated. That also means more vibrations between the platform and the turbines. We don't know the effects of those. There are no prototypes. It also means very large blades, which turn at a very rapid pace, which is going to chop birds, and it makes a big difference. And there is no precedent, really, no precedent. And this is why some institutions, such the Science Academy, are saying we don't need additional power for 10 years. We don't need intermittent variable energy in the current context of power in France. Decarbonation of floating wind farms is very questionable. The impact on carbon is negative. So we are asking for a moratorium, immediate moratorium on these massive floating windmills in north and south and northeast Brittany, and we would like to get the support from the scientific community. Thank you, sir. Hello, and thank you for your question. I will answer the first question. Yes, the slides of this event will be made available on our website. This conference is also recorded, and the recording will be made available to all of you. There are additional deliverables and a summary report, which you should have received this morning, which is about 10 pages long. We have another summary report, which is approximately 100 pages, and a more detailed experts report, more than 1,000 pages, which will be published in September. All of those will be available on the CNRS and IFRAMER websites. And we will continue to keep you informed as much as we can. We're not going to limit ourselves to this morning. For the other questions, I'm going to give the floor to my colleagues. Well, I won't say anything about the tender. We were here today to present existing knowledge, and we hope this will help the general public, and it will shed light on some of those issues for various stakeholders, and hopefully it will serve its purpose. Once again, a published report will be, the detailed report, I'm sorry, will be published in September or in the fall. But as you see, as you were able to see, the summary report gives a lot of information already. So make sure you use the results that will be published, and decisions, unfortunately, are not taken by us. Okay, next question, please. First of all, thank you for the results. It seems very comprehensive. I have a question about the methodology. Are any articles of the grey literature used in the corpus? And if not, why not? Well, at ESCo, we use literature published in scientific reviews. So some were automatically eliminated. In some instances, very occasionally, we've used some institutional literature, high quality literature, but it's only a minority of the study. So there is also the study on Biotop on grey literature. We, of course, looked at their conclusions. We looked at the consistency between their report and ours, and I think they're very complementary. What is grey literature? Well, grey literature is literature that is not necessarily published through official channels. It could be PhD reports, institutional reports. Okay, thank you. Yes, sir. Sébastien Tourin. The number of wind farms is going to increase along the French coastlines on different seabeds, unstable seabeds. Some will be artificialized. In some instances, I've even heard about artificial reefs around wind farms, which is going to have an impact on the environment. How are we going to offset some of the surfaces that are going to be completely modified? Technically, can we do it? And if yes, how so?
Sylvain, would you like to take the floor? Very briefly. Well, to offset it, we need a significant impact. And there are matters in terms of tools to assess the impact of these negative effects. I mean, it depends on the losses at the level of the footprint of a wind turbine or pump and accumulated effects. You need to measure all three, not substitute from one for the other. I don't know if Stephen's still in the room. Stephen de Greur? An article was written by an expert who was in our group on the different natures of these structures and the objectives associated to them. There's the importance of making a difference between the restoration of species and habitats that have disappeared from structures. Ah, Stephen, here you are. Would you like to answer instead of me? Yes, I would. I don't know how to answer this question, actually. The impact of the effect of artificial reefs is... Oh, you need to put the mic closer to your mouth. Okay. So the artificial reef effect is very specific. It depends on the environment. So loose substrates, it's an artificialization of this. But bear in mind that the direct impact of artificial reefs is very local. So when you talk about a wind park, tens or hundreds of turbines, some effects are not localized. They'll be in the whole park. The enrichment, organic enrichment, for example, is something we'll do. On the other hand, parks who stay for 25, 30 years and then they're decommissioned. And what's very important is how the system when it's been removed, when you've decommissioned, what's going to happen when you've decommissioned the park, when it's been dismantled. That's very important to talk about. Thank you. A question, please. Jean-Claude Génard. I'm the chairman of an association in the Éoliennes region. I'd like to have a question, just a few minutes for my testimony. For 50 years, I've been a diver. Yes, half a century. Between Edic and Noirmoutier, I know pretty much all the sea bottom, both on the coast and also on the plateaus. And for 50 years now, 25 years, what we've seen is this disappearance of maritime ecosystems. We all know the role of these ecosystems. They're crucial, and we need to act quickly. There's been lots of studies, lots of scientific inventories to show this disappearance. We've mapped all this, and in 2023, we started restoring some habitats in a very complex habitat in the Pouliguen Bay. And it's working. For 2 years now, it's been working. So we're going to reproduce it. One quick point. The effects, positive and negative, on a plateau that's a few K from the first wind turbine, the Channel Plateau, when the turbines were placed, piled in, what we saw was lobsters following and crossing the whole area, 5 on 10 square kilometers, say 35 lobster traps. Sometimes you've got 40 lobsters in 35 traps. So it all started here. And also, octopi came to the coast. We saw a disappearance of these octopi, of these animals. The octopi ate the crustaceans, no more predators to eat the sea urchins, and this amazing area, there's no more luminaries, so sea urchins are everywhere. Total chaos. In the face of his proposals, what we say is this is the damage during the work. Afterwards, there's some issues, of course, for disappearance of these laminas pretty much everywhere. What we say, these spaces are pretty much protected. So these shouldn't be sea reserves, but places where you could have bio-inspired reefs to create fishing resources, fish, lobster, and so on. Associate ANTI so, whole sectors on ropes that could, on the one hand, be carbon sinks and also have an important effect on the improvement of the quality of water. These are my proposals. Because let's not forget that those who build these wind parks have had a wonderful, have hugely profited from this. Thank you. This is a comment, a testimony on the importance of restoration. We talk about restoration in this chapter on mitigation measures. Our angle was in comparison with sea turbines. We send people to scientific literature, i.e. documented work on the restoration strategies. Even nowadays we see, as Sylvain and Catherine said, on sea turbines, these restoration strategies haven't proven their effectiveness. So wind turbines, restoration, we need to work on a proof that it works. And it's going to depend on the type of ecosystems. It can work in some ecosystems and not other ecosystems, dependent on the strategies that are implemented. So we need to be very careful with how for science to support these mitigation strategies. Restoration is one of them, but we need to prove its effectiveness. And we were talking about integrated agriculture. So we don't have many articles on this in our corpus, but there is one interesting article that talks about seaweed culture and the advantages it could represent with a combination of it. So Xavier Gaito, Friends Officer Biodiversity. I work with Ministry for the Environment. Very briefly, one comment. I'd already congratulated you on your approach by pressure on OBV is structuring. It's a very structured approach. It was the right decision to make. It's good to repeat this once more. There may be a bit of a frustration because you didn't give me any meta analyses. And we wonder about our ability to have articles that allow us to do this. Considering the size of your corpus, I was surprised you weren't able to do this. I was also surprised we're in 2026, but we have no information on functional ecology. This is quite surprising. I'd like to share my surprise. And my question is linked to your proposals in the conclusion. You need to look at the cumulated effects, both in the types of group, but also in terms of scale. This is not just my wishful thinking. I'm implementing public policies. It's interesting, but I'm not going to be able to use it for a few years now because it's quite difficult. My proposal. Could we not just say, you talked about this need of conserving and implementing long-term monitoring. This is important, I agree. I think it's an important element, but could we not also find, I know you're going to say no, but in your work, could we not find major pressure groups? You'd worked on the couple, pressure and group couples, could we not work on these more in depth, more intensely, to take these elements into account more precisely in choices that will be made later? Thank you for your question. I'll answer your question, but I'll let Sean answer the statistic question. Thank you for these questions. An intern was working on this aspect. So we have lots of articles on some biology pressure couples that are well studied. After 6-month work, we didn't have enough articles to do much. The statistical methods were varied, and there wasn't enough information. The only meta-analysis that's published on this subject was Metrata in 2019. It was on the abundance of fish in offshore wind. There's not enough studies that use a similar method to do this kind of analysis. Thank you, Sean, which is why we recommend standardization internationally speaking. Your question on how to assess the cumulated impact. My work on cumulated impact is modeling studies, and there's going to be maritime biology as well, and a multiplication of parks. All these models need data from the ground to be validated, because we're talking about very large scale. We work on restructuring data exchange internationally speaking. You can talk about the role of some international structures that we can base ourselves on, ICES, OSPA, and so on. But anyway, we see in France that it's difficult to exchange data between interpark data. In Belgium, there's more integration at the national level. We need to go further. There's international structuring work, which is very important. As for your final question on this major group couple, for your comment on cumulated effects, we need to work on high entropic effects and not low entropic effects. So Alexei's presentation that showed how this circulation in the water and on the sea bottom, how complex these physical effects are. It allows us to, but we need to see the impact on plankton and primary production by phytoplankton. One quick comment on this matter of cumulated effects. We've got a chapter in our report on this matter of accumulation and the hierarchization of effects. We're not able to do this absolutely, so this hierarchization of effects, this accumulation of effects based on case-by-case studies under expert methodologies. There's lots of uncertainty. Methods exist, which we've reported in our report. Experts who know the subject and the place of a project established scores on pressures and the main effects, the hierarchization of these pressures. It's not exact science, but that's where we decided to stop. One quick addition here. We showed that this is an EBV that's not very representative, and it's a way to go further in its connectivity studies. Sir, thank you. I'm a sociologist from the CNRS, Mr. Andai, I believe. I've got a question on the method, this distinction between the article and the study. In an article, we can have 4 or 5 studies. I don't know how it is in your scientific field, but there's this question on enlightenment. There's an article on a protocol, an implementation on the ground, and these targeted results and results on other organisms and dimension. So on this breakdown between study, and this setup with studies and articles, was there this demand that every result be well equipped with its method? That was one question. And secondly, on the economy of knowledge, you took the peer-reviewed literature, didn't you? Grey literature isn't taken into account. So everything that's impact studies, that's produced by the development of wind power, that takes in lots of knowledge and money, ability, and exploration abilities. All this is not taken into account. The other study, which you mentioned earlier on, is based on grey literature. So my question is, do you have an idea in your 167 columns, is there somewhere where you've looked at the origins of the funds and these results you give us of the the results of studies that are financed by public funds. What do public funds pay for? And is there this difference between studies and difference? Does it not tell us where we should funnel the money to produce knowledge? Because it feels like we're basically jumping into this very deep path without knowing where we're headed to. So we need to see where we're going to. Your answers now. So we have lots of information, and I think there were several issues here. This study article matter is very much based on the questions that are asked on each pressure. For some pressures, it's important to look at the answer at the level of a study. And in this case, in these articles, the lines that constitute the taking the info of the article, of the study, will be at the level of a species, at a more global level, like what Shen presented very briefly. A study will be a biological group, so we are asked to define studies very precisely, dependent on studies that are presented, because we have a macro approach on the whole corpus, or we've got an approach by pressure. So the details will be in the report and the synthesis. That's where the definition, every chapter has a very precise definition what's underway in the study. As for the contextualization of the scientific work, one thing is clear. Lots of work is done in scientific projects with public funds, in collaboration with operators. We don't necessarily have a trace of his funding, but in the corpus, we've identified the wind parks that were the object of a study. So we've got the exact location of a work carried out. Then you need to go to the articles and see what the sources are funded. I mean, they are often indicated, scientific art. All scientific articles have an information on conflicts of interest or link of interest. It's clearly identified in his articles, but we didn't extract this information. Just to add another point, this matter of interoperability of data stresses what we were talking about on the use and what did grey literature do in terms of complementary information. It can only give complementary info to an ESCo if it goes through the whole mill of research and published in a scientific review. So basically, ideally, we'd like to have all this data, and it's not always in usable formats. So there's an improvement of the interoperability of the data. We have very little time left. Let's try and work on two questions very quickly. Sir, good morning. Can you hear me? When you do the bibliography on this kind of matter, I did this as a thesis rapporteur, we really are struck by the amount of work which concerns potential effects. In your article selection, you mentioned 40% of the articles, in this case, on potential effects. So in this context, I'm actually surprised that IFREMEF and CNRS do not focus more on project carriers, those that manage wind parks, to give access and for observations of what really is going on in the masts of the turbines, for you to really see. The second point I'd like to talk about very briefly is when we talked about the ERC sequence, do you not think that the rare work on this ERC is due to the fact that the place was decided upon previously by politicians before scientific studies confirmed it? Thank you.
So, on ERC avoidance, the A of avoidance Any thoughts? Well, again, the focus of ESCo was not that. What I do know is that there are regulations that impose a number of rules, including the obligation to provide information on the characterization of habitats once collected, after those have been collected. So this needs to include the initial status. So that information is very useful when defining the specific location of a wind farm. Sylvain, there are a number of planning, strategic documents. When you plan on such infrastructures on sea, it requires an environmental impact study. And once you've identified an area, specific research needs to be done to identify the most sensitive habitats and ecological functions that could most significantly be impacted to be avoided. With Catherine, we made a distinction between reducing avoidance, which means no more negative detectable pressure. And there are many measures in the identified bibliography that were identified as offsetting. We consider them as a reduction because it was not demonstrated that that the negative effects were completely suppressed. So it's important to have the right tools. As we said in the presentation, there are scientific knowledge gaps that need to be filled to improve the offset or avoidance. And the last part is a public study during which the general public, like you, can verify whether there is a proper response. So citizens have to be well equipped to do so in order to verify that those 3 steps have been followed. That is definitely what the experts have called for. Okay, let's take a last question. Sorry, comments in the room are made without a microphone. Yes, sir. Mathieu Hébert. I work with a development company called EVO on offsetting or avoidance. I'd like to make a comment. It's all the things we don't do, and they're difficult to quantify. My question is on the method or the methodology. When there is very limited information or information spanning over a very limited period of time, have you explored what has been done in the oil industry, offshore oil platforms, for example, and if certain things could be transposed, or is it absolutely irrelevant? Well, we talked about analog. I think that's probably what you're referring to. As you said, there are other human industrial activities that have similar types of pressure, including the so-called reef effect. And there is some literature, scientific literature on this. There are also meta-analyses on the reef effect that have been published. And so we did look into this. As long as we always include air farms, air or wind turbines. So yes, it is possible to extract useful information on effects coming from other publications and other industries. An interesting example would be decommissioning. As I said, there are 3 studies on decommissioning. There is additional research which exists on systematic review on decommissioning, which was published in 2023 and 2024, focusing specifically on offshore structures that were decommissioned, dismantled. And in those systematic articles on decommissioning, several questions are addressed, such as what decommissioning or dismantling options exist. Should we have all options? Should we go through all the phases? Should we fully dismantle, decommission, or not? So that is something we've definitely looked into. On non-indigenous species, we did this. We had 4 studies, and we thought it would be a bit unfortunate if we kept it there. So with our documentalists, we looked into scientific databases to find additional information on analogs, harbors, offshore platforms, and artificial sea reefs. Ladies and gentlemen, this is it for the first section of this morning. We are going to have a very short 15-minute coffee break before our roundtable. Let's meet again at 45 minutes past the hour sharp. Thank you.
peu en retard sur le timing, donc si on veut vous libérer également pour le déjeuner, pas trop tard. Merci de vous installer. On va commencer dans 1 minute. Voilà, on va prendre place, s'il vous plaît, pour commencer cette discussion, cette table ronde. Voilà, entrez, installez-vous s'il vous plaît. On va commencer. Si vous pouvez vous asseoir. Allez, on va commencer, s'il vous plaît, parce qu'on est un petit peu en retard. Donc, si vous voulez déjeuner à une heure décente, on va commencer cette table ronde. Donc, on va évidemment pas refaire la...
Welcome back. Welcome back. We're going to now start the roundtable. We are going to see how all the knowledge presented this morning can help decision makers and other stakeholders organize their strategies. We have Jules Nisset, Daniel Kneff, Xavier Guillou, and representing the European Commission, and Pierre-Yves Hardy, who is with IUCN. So, Pierre-Yves Hardy, Chairman of the Marine Renewable Energy Working Group of the French Committee of the International Union for Conservation of Nature. What are the main takeaways for you? Well, I worked on the theme committee with IUCN. We worked with scientists and operators. We have been in a dialogue, a very positive dialogue, for many years. We have published a number of reports. Here they are. I have dozens of reports on the topic of biodiversity, and some conclusions have been published. We talked about cohesion, marine mammals, benthic consideration. All this is very well known. But for the first time, we have a very epistemological approach, I think, of unprecedented comprehensiveness. So I think it will put an end to a number of controversies. And we should use it as a scientific foundation. And we may not always agree. Operators and scientists don't always agree. But I think that for once now, we have something that is no longer questionable. Scientists have done their work. As scientists, they are not taking any positions, but they can make factual recommendations while showing the truth. So they've done most of the work, most of their work. So I think it is now our responsibility to continue and draw the necessary conclusions. One clear message is that collisions and cumulative effects have to be better studied and measured. I think we have enough with this report to make decisions collectively. Jules Nissen, you're the chairman of the Renewable Energy Union. Does this study confirm some of the knowledge you had or not? No, nothing really surprised me. Most of the things that we heard this morning are confirming past research and data we already have. But scientists did a good work using the right methodologies, and I think it gives a very comprehensive overview of scientific findings, and there are no contradictions with what we already knew, but it's more documented with more bibliographical references, and that's very positive. When you study a subject like this, and mind you, we're only in the early days of wind farms, the amount of data we have to process is huge, and obviously research should continue. What I'm going to take away from this study is the notion of complexity. There is no absolute truth behind this. The impact on biodiversity still has to be further investigated. We need to obviously look at things one by one. Scientific research covers specific types of installations and facilities on specific types of seabeds. So we need to, we can be general, but at the same time, we have to accept to work on a case-by-case basis. Right, but would you say that you have a strong scientific foundation with this? Yes, absolutely. And again, it doesn't really go against any of the knowledge we already had, so I think it is very useful. Daniel Cueff, Vice President for Marine and Coastal Affairs in Brittany. Did you have any concerns about this study? Well, yes, because it is a study which is commissioned by the state. So my concern was, what are they going to come up with? And there was a little bit of suspicion. Maybe they're going to come up with a study to tell us that all wind farms should be the same everywhere, and that is not what this study shows. So we were wrong. We were wrong when we were concerned. As a matter of fact, I think this study highlights some very interesting facts. First of all, collectively, politically, we decided to do things the right way. in an organized way, in a coordinated way. So, in other words, science is helping us, is directing our efforts. And in the studies that were covered by this investigation are numerous, and there are additional impact studies that do back up some of the findings. What they show is that there are certain specific items that should be taken into consideration. In the Saint-Brieuc area, there has been extensive research on wind farms. The maritime prefect has asked for those studies, and they have shown that the studies have shown that there is no impact on the fishing industry. They have worked on noise. They were using different technology, including screw technologies rather than knocking with excessive sound. Do we have the same knowledge at this point about fauna, especially migrating birds? It's interesting to see how operators are using the services of experts, companies, engineers, because there is a risk of collision with birds. And the real underlying question is, what can we do? There is extensive research to identify migrating birds, identify when they are likely to arrive, what itineraries, and we've also seen new systems where the tips of blades have a different color to actually signal to birds that they should not go there. So I think we all agree that we need to protect biodiversity. So we've had multiple presentations. Some of them showed the complexity of the impact on wildlife or the effects on wildlife. Pierre-Yves Hardy, how do we manage this complexity? Because we're adding complexity or more complexity to complexity. So we're talking about we're modifying ecosystems for the next 25 to 30 years, and it is very difficult to predict, anticipate what the effects will be and how much we're modifying and how well the marine environment will adapt. Of course, ecosystems were what they were, with various types of seabeds, sea rocks. So we're really entering a new chapter of marine environment and knowledge. Will those modifications be positive or negative, and how will they impact resilience when it comes to global warming? The answer is that nobody knows. At this point, nobody knows. Therefore, we have to be humble. And the entire report is very much inspired by humility. We have to be humble, and we have to constantly apply the principle of precaution. Xavier Guillot, you work with Maritime Affairs at the European Commission. What's the perspective from Brussels? And what do you think about this study, which was carried out over a long period of time? Hello, thank you very much for having me. What struck me is the great deal of effort behind this study and the multi-domain and multidisciplinary approach, and also a reminder that science should influence public decisions. And in the introduction, I think it was clearly mentioned that the stakes are high, the societal stakes are high for Europe. because Europe is seeking to accelerate its energy transition with a focus on renewable energies. There is a new survey on public opinion which shows that on average between 80 and 85% of Europeans support renewables. This was before the crisis in Iran. And there is also increasing demand to understand what the impact is. We know that windmills, wind farms could potentially play an essential role. But how good are we at having a proper dialogue with local communities and residents? So this study shows that it's important that we need this kind of scientific expertise and knowledge. Turning to the representatives of the French state, you insisted on the fact that this is an integrated effort between different ministries, maritime planning, energy, the Ministry of Ecological Transition. It was very much an integrated approach, and I believe that this is the right thing to do. We must work in an integrated way. You and us. We all have to conduct an integrated effort. And I think that some of the conclusions of this study are reinforcing the conclusions we already had with different working groups on the North Sea. Maybe we will come back to cooperation between neighboring countries. Would you say that a document like this can meet two objectives which sometimes are seen as a contradiction, climate on one side and biodiversity on the other side? Well, I don't think we have much of an option if we are going to address the biodiversity and climate change. They are very much connected, and that's also part of the European Pact, which we presented last year. I think it states very clearly that the two are tightly connected, and I think it's also an opportunity to explain to inform the general public and everyone else that the sea is a very complex environment. It's an obligation to make this transition successful. Danielle, QF. We talked about the public debate. A document like this will probably fuel this public debate. And do you think it will increase the general public's trust? Well, I have had many public debates, public discussions, town halls, and acceptance is higher when wind farms are somewhere else. When the state says, when the authorities say, well, we may consider such and such area, then people react. And we systematically face the same companies. Some are the ones who are promoting degrowth. They're saying we need less power, we need to reduce power consumption. And we agree with that. We need to reduce overall energy consumption around the globe. But most importantly, we have to replace fossil fuels by renewables, because they're very negative, very detrimental to biodiversity. And also for geopolitical reasons that are becoming increasingly obvious and significant. We are buying our oil and gas. And when you choose a country to buy from, you choose a dictator. The people we buy those fossil fuels from are not our friends from a democratic standpoint. Then you have the pro-nuclear people. They say we need to stick to nuclear power and we need to accelerate the production of nuclear power. And they claim that offshore wind farms are actually causing us to be behind, to start lagging. Well, when you look, you simply need to look at the facts to address that one. The third group is the more complex one. It's local residents. those who live nearby and those who claim that their homes are going to lose value, which has never actually happened, and some who are genuinely shocked, moved, and who get very emotional around the fact that you can see those wind farms. I personally find them beautiful, but for them, for many of them, for many local communities, those wind farms, they claim, are going to change their lives. And they get very, very emotional about it. And fighting emotions can be very difficult. And sometimes you have to accept emotions and recognize that emotions are legitimate. But these are the people who we're struggling with the most. Because Pascal's Jules Nissen, the study also reveals a lot of uncertainty. Do you think that this uncertainty means maybe we should slow down the pace or not? Well, I don't think the industry decides for itself. The industry will do whatever is decided by the authorities. I agree with what Mr. QF just said. All this is part of planning. It's generally multi-annual plans, state plans, and based on those plans, new wind farms are developed. It's not the industry which decides for itself. We have, for decades, imported fuel and energy. Today, we need infrastructures. If you look at aerial views or satellite views from the Gulf region, what you will see is drilling platforms all over the place, gas platforms, and that is something that we never really understood. We never really grasped. If we're going to produce locally, well, we're going to have more infrastructures on our territories, and which is something we never really had so far, and that is going to have an impact. And this impact will generate reactions from local communities, residents, people who protect biodiversity. But you can't just tell people there will be no effects. There will be effects. There will be impacts. But once we have a clear framework, which is defined by the public authorities, we have to do our best. Simply do our best. And we think there are a lot of constraints, and we have to navigate those constraints. We have to protect biodiversity, and at the same time, we have new obligations in terms of energy production. I think that the research which was presented today is extremely helpful. And Pierre-Yves Hardy. Well, yes, I agree. I think we have to. We need a new energy mix, but I can see an issue between this and what we heard today and what we heard 2 years ago when we talked about scientific or science-based planning. We have some state representatives in this room. And we know how difficult it is to make decisions. We know we are lagging. We have to catch up. We have upcoming elections. Today, important political decisions must be made. And we have the impression that some time has been wasted. Some operators are concerned and are even thinking that they may be accused of being responsible when it is the state which is responsible. It's a very complex equation for everyone, including the state. But I think that this, a lot of this, the science that exists is science that has been around for years. It's been repeated again and again. And even on cumulative effects or impacts, there have been several additional studies that were published recently, and it raises a lot of questions from the general public. There are some studies receive massive investments, 5, 7 million, and nothing happens. Nothing happens. Nothing comes out of it. We thought until recently we had a small political window, which was still open, things may happen. But here we are. The state finds it impossible to take this research into consideration. There will be cumulative impacts, and eventually operators will have to conduct impact studies, but they don't necessarily know how to do this. I know that some of you are designers or research organizations. Maybe you should work with the state and again, make sure that the decisions are made. So how do you explain that the state cannot take such studies into consideration? Is it that they can't or that they don't want to? Well, I think both. Both. We have a legal document, a DSF, which is a strategic coastline document, which was published last year. We talked about ecology, but I think the most important thing that it's seeking to address is how maritime spaces or marine spaces should be used. And so this expertise, I think, is a new opportunity yet to raise questions. And I think we really need to reopen this chapter in spite of the DSF. I think we need to continue to investigate what areas we can choose and how we can make sure that we preserve biodiversity. I don't think nobody does zoning while deliberately ignoring research or studies. The knowledge we had in the early days of zoning is not the same as the knowledge we have today, and there is probably a lot more to come in terms of knowledge. There has been a massive tendering process for different areas along the coastline with the public debate, public investigations and studies. And there are some areas where the selected operators will have to adapt their project as much as possible to the constraints, to the local constraints. And I don't think that the fact there has been a tender, puts an end to impact studies and pressure issues. There is room for adjustments. Again, the very starting point is to understand what kind of energy future we want. We could have no wind farms, and that would probably put an end to all debates, but it would raise new questions. My impression is that so far, all stakeholders have had a very good dialogue, but it's a very complex subject.
Xavier Guillou, what about the European scale? The state of knowledge, is it enough to feed into maritime policies and their current revision? Well, yes. Most certainly. Now, offshore wind is one of the pillars of the energy transition for Europe. But in an environment, a maritime space that's in movement, well, colleagues work on offshore wind, but also plans for identification of restoration at sea as well. So there's lots of variables that are changing, variables at sea, that is, that are changing, including the situation of future offshore wind parks. So there's multi-domain knowledge. We talk about the cumulative effects, not only the wind installations, one or the other, but also human activities at sea and how can we take stock of the maritime environment, basing ourselves on this knowledge, basing ourselves on the models that we'll develop, and how to identify the best sites for this very dynamic, moving whole, which also integrates elements of climate change that are accelerating. And areas for and the need of knowledge to be renewed. So this stock taking is very important. And I think when you quantify domains which represent potential risk, listing many potential risks if you introduce one infrastructure at sea, what could happen here? This is quite well documented, but being able to document these effects and answer questions on the state of knowledge that's insufficient or non-significant impact. This is a very important impact for public discussions, for public debates. Moreover, it's an invitation for scientists and public authorities to work hand in hand with their European colleagues, because the same questions and same issues are asked in exactly the same way, maybe sometimes a few years earlier on, sometimes on new themes like floating wind, because all these countries have a similar geography. They're going to move to floating wind. The Brits, the Irish, the French, the Spanish, and the Portuguese are going to move on to floating wind. We're talking about a pipeline of calls for tenders that's equivalent to everything we've already installed in Europe. So this is a new area for spatial development and a new area for the development of knowledge, which is all opening up. So this needs to be worked on in more detail. As for the usefulness of these results, the matter is identifying what we don't know and what we need to know. So we need to move forwards and better in energy transition, administrative, regrouping knowledge and making decisions in a documented way. So one of the things to do is to anticipate this knowledge. We know that we need to document, basing ourselves on spatial maritime maps. We can document for places where we can have these wind parks. We don't need to wait for the call for tenders. We don't need to have an impact study to launch a project. We can launch European projects on the potential impact of floating wind. We'll need this knowledge very soon. So there's lots of knowledge. If we stick to our course and maintain a direction in terms of volume and transition, there's lots of knowledge that we can anticipate. This study is going to guide future work, accelerator needs, including for France, which will be one of the pillars of floating wind. I think there's a specificity, a French specificity, and that it's a motor for European cooperation in these areas. It's not the countries of the North Seas that will initiate this work. They'll do fixed wind. Their waters aren't very deep, so at the short term, they're not going to focus on floating wind. So leader countries like France have some experience in this domain, and they can guide knowledge and accelerate the development of all this. Daniel Krief, could you illustrate what could happen in a region like yours in Brittany? So when you make a decision, what does this kind of result give you when you are working on a site? Well, you need to see the place regions take. The state has a responsibility of rolling out energy. So the state decides on the implantations. But the state has gotten used to not doing a thing without the regions. Best not to do that. Best not to So nowadays we're in a very positive situation. We can talk about the specifications with the GGSE. We can talk about the conditions for the acceptability for the people of Brittany regions, but my colleague from the Occitania region would say something similar. The fact is we need zero impact on biodiversity. That's crucial. In other words, we call upon associations for general interest, France Nature, Environnement, Rivière de Bretagne, and the League for Protection of Birds to say if there's a risk of impact or not. These are associations for general interest. So we call upon a second thing. We want socio-economic consequences on the whole territory, both in the ports, employment, training, company creation. We need economic consequences because this is an industry that is settling just off our shores, and it needs to have a positive impact on the territory. So we are working with operators in a concurrential dialogue to lead them to take into account the measure of what each of the regions could do for the rolling out of this project, operators project. So this is important. The impact must be on that. And the third impact, we don't. So we will be very much against the management of the fishing in these parks. We want these to be fishing parks. Even if they're floating, people must be able to fish there. When you say fishable, it's not fishing like we do nowadays. It could give us the opportunity to revisit some fishing techniques and choose fishing techniques that have less of a negative impact on the environment and biodiversity. But we don't want parks to become biodiversity reserves where there's no economic activity. This is the case for Brittany, because Brittany and fishing is the same thing. So we need to support coastal fishing because we need to work on the ability that we have to supply proteins ourselves instead of attaching ourselves to buying salmon that's been farmed in awful conditions and fed artificial food, fed by our Chinese ships with kilometers of nets. So we need to give credit to this kind of fishing, and it cannot be harmed because of the arrival of these wind farms. So this is why we talked about this document stratégique de façade. It's not a fixed document. It's a strategic document that's on these topics, depend on constraints, wildlife, fishing areas, co-visibility, defense, maritime transport, and so on and so forth and so on. We're in the same posture as the French government. We want the sea to belong to everyone. We want co-usages, we want co-activities, and we don't want to privatize the maritime space, even if it was for wind. So this is very important. So we look at this implantation very closely. And we told the operators we were in a rock-by-rock approach, negotiating things at a very granular level, where this implantation and ourselves, basing ourselves on these environmental impact study that is due by the state to the people, where they tell us you can't touch this or this. This is very important. Pierre-Yves Hardy, this topic of fishing is very important in these wind farms. They don't want to become protected maritime areas. That's true, but there is this issue offering specific types of fishing. Just to react on what Mr. Kreff said, so the NPO, France Nation, Environnement and Living Proteins have already talked. If you want to listen to what they have to say, there's stuff online, so it'll give you enough information. There's enough existing information to tell you that lots of these issues there are lots of issues linked to these two parks, but there's a new chapter, co-usage. This is something you haven't talked about much so far. For years, this has been in silence. This has not been talked about much because of many other issues being on the cards. And fisher people, producers, and so on have specification, and they talked about there being less fishing areas, and some key actors wanted about access to these wind parks to be able to continue living off their activities. So this matter of co-usage of fishing leads, leads to lots of administrative question. How can you include an activity in an impact study? Are fisher people going to do an impact study? Who's in charge of what? Insurers, certifiers, and so on and so forth. It's a huge amount of work when we talk about co-usage. And there'll be more studies, technical studies on the compatibility of usage between wind farms and the fishing community. So what we want is a sustainable blue economy, which could be a miracle solution to this usage of the sea, but would still be something that nourishes us. So we basically need to be modest on these issues. We need to move forwards with care. There's projects underway on these co-usage studies, real questions. So the French committee of the UICN will in September set up a meeting on eco-conception, and the theme of co-usage will be mentioned. Experts will be invited, the states will be invited, scientists, operators will be invited to talk about this. On the morning of the 3rd of September, we'll talk about these matters. And there's also a question we'll ask later on cumulative impacts, monosector cumulative impacts, multi-parks, and coastal sectors. So the UICN has published points on these matters. We can maybe roll it out on the theme of sea waters in France. So when you talk about the maritime space, there's several actors. At the European level, the fishing sector, maritime sector, infrastructures, at sea, coast guards, people who save people at sea. Is there a dialogue between all these different actors? Yes, there's constant dialogue. I'm in the European Commission that's in charge of maritime affairs and fishing. We have about 90% of my colleagues who work on the management of the common fishing policy and aquaculture. That's a subject that we're very much interested in, and we have discussions on spatial maritime planning, and it goes beyond these matters about sea, wind. There's questions on identifying zones of protection, strong protection management. So basically, it's the management of a maritime space and how we organize it, because the fishing activities are at stake here. We've seen all these dynamics are very complex. These are not plans that are complex as such. All these variables and models and dynamics that we're trying to fit into a very constrained space. The fact is, these plans are imperfect, are being revised. It's a base of common dialogue with the whole maritime sector, with the users. So the maps are very helpful for information. It's helpful to see that in the North Sea, 1/3 of the maritime space is dedicated to maritime transit, because there's Rotterdam, Hamburg, and so on and so forth. So there is a lot of efforts focused on the security sector and security protection areas to avoid accidents. That's non-negotiable. This is a dedicated space to this almost exclusive space. So There's a new point like at sea. Wind with fixed structures leads to a new variable with activities that are mobile and, well, you know, you've got limits like the coast guards, just like, well, the fire services on the land, they need to access all these installations to see how it works with emergency access, helicopter access, and it's quite fascinating, really, and it's very dynamic. One important point is that the sea is a public domain, unlike land, which is mostly private. Sea is a public domain, and it's the responsibility of the public authorities to decide of how it's attributed, allocated, managed, and so on. And this is a long debate as a public authority on the science of the sea. Jules Nissen, in the current context, is our sector under tension with the development of its at-sea wind, which meets major energy objectives. This is a very tense context for the sector. Well, it depends what your perspective in the economically, well, there's decisions to have calls for tenders for the sector. They're very behind schedule, and this disorganizes things. We started structuring the whole sector. There were plans for the assembly of wind turbines, you know, cables, blades, and so on, where they had to slow down their activities. So this is a sensitive subject. It's at risk. It's very much at risk if we don't have clear visibility. There's a call for tender. We'll see what the results are. If it's fruitful, if it works, I think it's going to give us a clear framework for the sector. Then the tension is linked to everything that is debate. I'm putting myself in the place of a developer who's won a call for tender for a batch, for example. So when you have to develop a batch of wind turbines in a place or another, they're faced with all these demands. You go from the responsibility of a state, you ask for the developer to be answerable. Now, also, the fishing community, I think there's been quite a lot of information on this, actually, and I agree with what Daniel Queff. There is a matter around floating wind. These anchoring cables need to be looked at. There's studies underway. We need to think of all that. And actually, at-sea wind is taxable. It's the tax on off-sea wind. This is a tax that hasn't been attributed yet. How could it be used to profit different users, regions that invest in port infrastructures for stakeholders in this sector? The wind sector can help fish and decarbonate, reinvent themselves. So we need to think about all that. How can part of this money be reinvested in the fishing sector to meet different issues? What's blocking things is the rules for the use of government aids. But we talk about this with the fishing community. I think we could have a win-win solution.
A quick word about technologies. Wind farms, the wind farms we see today, are they likely to change in the future? And if yes, are they expected to change a lot or not? And what will be the scientific impact? Well, I don't think that the expected technological changes, mainly related to size, with a limit, because there is I think we've somewhat reached the maximum size. Right, someone was talking about the size of the Eiffel Tower. Right, about 300 meters high. The problem is the bigger you build, the more complex it gets, both for floating or seabed masts. And it's not always offset by productivity. There are improvements that can be made in the field of blade aerodynamics, systems to avoid collisions, night signaling of wind farms. If, for example, where a signal is triggered only if an aircraft is in the area, for example. I don't think that as far as blades and rotors are concerned, we should expect anything completely new with new scientific implementations or implications. When it comes to the anchoring, the seabed anchoring, if we develop more floating systems in the future, well, then obviously we're going to have to rethink a number of things on floaters and how floaters are connected to the seabed. That is something that is not very documented as opposed to masts that are directly on the seabed. How about wind farms that are further away from the coast? Well, that's an option, but the problem is connection. They have to be connected to the grid. And if they're very far away, you need to pull cables, very long cables, and the further they are, the more expensive it gets. So it's all about trade-offs. The Renewable Energy Syndicate did some research on this at the time of offshore planning. And one of the questions is what happens if we go really, really far away? Beyond MPAs. Well, the problem was cost. The cost makes them completely inefficient. How about you? Are you also keeping an eye on the latest technologies in wind farms? Yes, absolutely. Ifremer has been pretty good in prospection, and it would be interesting to do some research on the future of wind farms. Today we're seeing concrete barges. The French are really good at concrete, for example, so floating concrete is something that could answer some of the pollution/pressure problems. So this is something we need to look into. There are different kinds of systems that we can develop without necessarily looking for the so-called reef effect. Whatever we put in water, in the seawater, will be colonized by living organisms. So we have to think about this. We must keep this in mind. But who knows? Maybe we are at the eve of a new era. The future of the wind industry is going to be very much based on eco-design with the objective to reduce pressure, reduce pollutions, heavy metal pollution, the impact or pressure on some species. We also need to think about new connectivities. There is a lot of innovation to measure reductions. We are finding it difficult what the mortality rate is of birds, for example, and fauna, more generally speaking. We have to invest on these new reduction measures. Again, offsetting or avoidance is the best option, for sure. Quickly back to your question on the future developments of wind farms. I'd like to say a word about operators. In the future, operators are going to have the burden and responsibility. The TSF, the DSF, this strategic coastline document is based on a strategic environmental assessment before we decide where we're going to build a facility and when. Since 2018, IUCN has published a number of reports to explain in a very simple way. The state is responsible for planning. The state chooses which locations are going to have wind farms. It's not something which is decided by operators. We're talking about the future, about 30, 50 years from now. If one day we discover an impact, what do? Do we remove everything altogether? Or do we replace or displace floating facilities? These questions remain unanswered in the strategic, in the DSFs. We don't know. scientists, experts could work on this. And I think ESCo, we don't want this report to remain stuck somewhere in a drawer. IUCN will contribute. I think we really need to simplify information, disseminate information as much as possible to avoid it stuck somewhere in a closet or in a drawer. And we should take all this very seriously. And what we don't want is someone to cut and paste or copy and paste the research by forgetting a few things. The work accomplished by ESCo should be the foundation of a new process moving forward. Okay, a last question, Xavier, before we move on to the conclusions. Most of the know-how, current know-how, is based on facilities that have been built in the North Sea, less so in the Mediterranean. How do you think Europe can change this? Well, I think the first message is that it's never too early to invest in science and know-how. We're starting to get some data for the Mediterranean, for France, that is. There are a number of countries that are showing interest as well, and there is a real potential. The potential is not as big in the Mediterranean as in the Atlantic Ocean and the North Sea because of the lack of wind. But Italy or Greece could definitely use wind energy because they're highly carbonated countries. It does take time. I think that right now our time and energy should be used to transfer knowledge. If the Mediterranean region decides to go for floating systems, well, then we should help them and with data on floating. And of course, there will be local specificities, but we think that as much as 80% of the methodological needs will be the same. Our job at a European level is to really find an interest in international cooperations. All countries, all administrations are under a lot of pressure to develop at an unprecedented pace. And again, the energy transition is no longer an option. We need to know precisely what has been tested, what species have been tested, and what is replicable and what is not replicable. Let's close with a final word to each of you. Daniel QF. I'm going to start with you. Could you give us your view about the years to come and how you think we can work together? What would be your final word? Well, I find this session very exciting. I think that it shows that democracy has not died. There is transparency. We have NGOs, operators, representatives of public authorities. We have a lot of information, objectivated information, and that is very useful. I think it shows the power, the strength of the wind industry. It is encouraging, it is accelerating research, and it's forcing us to know the environment more than we've ever known it. We've had very interesting research, scientific research. One from CNRS, Laurent Chevreau, with the impact of noise on scallops. And some said that scallops could flee, could disappear because of noise. They ended up not disappearing, they stayed. But it had to be demonstrated. So what's interesting is the fact there is a lot of controversy, a lot of democracy, a lot of convergence as well. So this is good. Xavier, what is your conclusion? I think we need to continue and work and mutualize. There are a lot of things that different ministries, research organizations across Europe have identified. There is there is a very high level of knowledge in marine biology and research, and I think it is in everyone's interest to work together to become more efficient, save time, and address very high expectations. Jules Nissen, how about you? Well, I attended an event this morning on hydropower, which is a very well-known but old type of power. And there again, there was a lot of research on rivers, on sediments, and I think there's so much we have to discover in the wind industry. And I'm sure that if we decided to hold this same event 10 years from now, hopefully things will have settled down a little bit, we'll have a better picture, and we will avoid caricatures. We need to continue and produce scientific information, knowledge. We need to continue and simplify and make this information available to everyone, because at the end of the day, we serve the general interest. So we need to reduce complexity. We live in a world with a lot of complexity where scapegoats are very easily found. Pierre Hardy for IUCN, well, as a member of science, and one of the few who's probably going to read all 1,000 pages, it will be my my main focus for this summer. It's interesting to see how little people listen to scientists. So I would like to thank the scientists for the great deal of work they have done. Doing this research, finding the funding requires so much work. And I hope it's going to yield intelligent decisions. Well, thank you so much. Thank you to all four. Thank you so much.
Ouais, je veux bien. C'est cool pour toi? Ouais. Ok, bon ben.
On vous a entendu, merci monsieur. On va terminer.
You have been heard. Now let's have a closing word to talk about the follow-up of his expertise. I'm going to give the floor to François Ollier, President and CEO, and Yves Rémer. François Ollier, you have the floor. Right. I'm ready. Oh dear, this is, well, quite a mess, isn't it? It's quite untidy. So what am I meant to do? Where's my speech? The interpreter doesn't have a speech, so she'll just do her very best. Well, it's almost time for lunch. Hello again to you all. I'm going to try and close. I took some notes throughout the morning, so I'm going to try and not be too long. The first thing I wanted to say, I've got 5 points. I think that what we saw this morning is sincerity and objectivity of a work that was presented. There's been analytical and systemic vision of this issue, this matter of at-sea wind and its impact on biodiversity. And I think that this topic was touched upon in its very complexity and it's in the respect of a diversity of a situation. This method of looking by pressure, looking at the main variables of biodiversity, all this seems to be an interesting way of articulating the systemic and analytical vision. That's what I maintain from what was presented. And as was said in the discussion, this complexity was revealed by the fact that 3 different ministries asked for this study to be commissioned. And there are many interesting things that were pointed out by Éoliennes. You saw the diversity of these experts, so the competency principle. This was an independent study, even though it was commissioned by the state. Transparency in its final roundtable. Partiality is also very important. And I also heard the fact that there were other works based on grey literature, but these are respectable works. In grey literature, we take this into account. There's a nice complementarity between the work on the analysis of grey literature or the analysis of data that comes from the operators and this scientific analysis that's done by many peers. Secondly, this analysis shows that if the knowledge isn't complete, their mapping cartography is complete. We've seen there have been quite a few gaps identified, but the work done by our colleagues covers all of the literature that's been produced. And 2 points that I think are important. This is new work in France and the world, and in a very large measure it comes from abroad. But this is work which I hope will be useful for foreigners and our European partners. It'll be useful outside of Europe. I've had the opportunity to talk about this at the World Bank as a president of EFREMER, one of the virtues of this work. Now, Amin said it was a demand of a state, but I asked for the study. Sorry. If we didn't do the study, we would repeat again and again the same study on different farms on the same subjects. So this, rolling out of knowledge at a larger scale is very virtuous. There's also the fact that there's lots of correlations and lots of realization, but in this work, there's stuff on the mechanisms linked to the effects. In a sense, as to a causal approach, which is important when we ask questions on all this. In the gaps, there's this systemic dimension of cumulative effect and geographic effects beyond the wind farm itself. I heard how we should put protected maritime areas, parks, the grey area, the landscapes and so on. This is very important. That's true. So quite clearly, there's need for more research. I heard Mr. Nissen say that if we meet in 10 years' time, we can take stock. Yes. This work is large scale. It's bringing on. It's 3 years' work for the coordinators, project managers, 2 years and more for the experts. We see there's this publication dynamic which will need to be updated. It won't be as long. As for research needs, I'll insist on 1 point beyond the landscape dimension and the need to look at accumulation is the fact that the need to give a model long-time access and also need for financing for this to be doable. This is a real issue. Third point I'd like to mention is that this collective scientific expertise shows that the public debate is made clearer, but it doesn't enlighten all of public experts. Scientists research, experts synthesize, and then decision makers decide. Expertise is there to enlighten the public debates. And it doesn't make any decision. Why are we interested in this subject? Just to remind you why it's important to have this work of the objectivization of the effects of an activity that's had a major role in our maritime ecosystems. Because there's a public policy on energy that's very strong on the topic. And also another point that was mentioned, there are public policies, national, regional policies for the protection of biodiversity. And these policies need to be articulated one with the other. And it's also, I'm saying just like that in passing, we've had a few testimonies and illustrations lately because the mitigation of climate change is a public policy for the protection of biodiversity. Next Thursday, my apology for talking on Domo and not about the CNRS. Next Thursday, we have a press conference on maritime sea waves and the impact they have on the health of maritime ecosystems. So we need to, look at things clearly. We need a strong mitigation policy of climate change, and this mitigation policy will be a policy to preserve biodiversity on the long term, even though there can be short-term effects that were mentioned in this collective scientific public study. There are many issues, political, legal, and moral too. And I think it's welcome that these three directions and these three ministries are here for us. And I also heard that we do this work at sea wind. There are activities at sea, and we ought to be able to compare the effect of these different activities and what the cumulative effect is on biodiversity. Final point on this part on the public debates. This collective expertise is done with the data we have now, 2024 until 2024, and this sector, as mentioned by Jules Nissen, is being rolled out progressively, so it's not necessarily something we can use to judge past actions. We need to bear in mind that our knowledge of the biodiversity of maritime ecosystem has grown recently. In the first slides we saw earlier on, we saw the dynamic of scientific publication. So the first call for tender on offshore wind dates back to 2011, and the first paper on the impact on biodiversity dates back to 2013. There's things that have changed over 10, 15 past years. So we can review the past with what we know nowadays, but in 10 years' time, we will see what we talked about today in the perspective of what we've learned in the past 10 years. And fourth, and almost final point, is the next steps. So you've understood there are three deliverables, two already available on the sites of the CNRS and Ifremer. I'd like you to read this synthesis, the summary synthetic. I've got the things that we haven't been asked to give a restitution in June or in a press conference. So we need to take this 130 synthetic document. There's a complete report in the autumn. It won't be a summer read, it'll be a Christmas read. There's a special review, an edition of a scientific review soon, and there will be a special issue in Environnement and Responsibility on our analysis. There's many communications on the topic, and I think that the CNRS and Ifremer agree to go and meet those who would be interested in having specific presentations of their work. I understand that this was a strong demand of the commissioners that this study not stay on a shelf accumulating dust. So we are ready to play this part on it. And you said this, so it needs to be shared. I think that's what our colleagues, our expert colleagues want to say. And I'd like to thank a few people. Firstly, I'd like to thank the ministries who supported and commissioned this work. At the same time as I'd like to stress that we were able to do this work independently. I'd like to thank the people who took part in the roundtable, who took the discussions beyond expertise itself. I'd like to thank Alain Schul, the project team, all the experts, in other words, the two pilots, the missions, the respective missions of CNRS and Ifremer that are in charge of public policies. Marion Cuif and Ifremer works on this, on the energy transition, and maybe thank the people who are in charge of communication at CNRS and Ifremer, because they tried to make it possible for this restitution to be done pedagogically. Thank you to the participants to today's seminar, both from at home and here. There's about 150 people hearing people, but up to 100 people connected online. So there's been about 500 participants for an expertise of this type. It's good. And thank you again for moderating these discussions. Thank you for your presence. And it's allowed us to finish on time. Thank you. Thank you, François. Now, maybe we're going to give you all the floor for conclusions. Madame Cazot. Thank you, Matthew. Thank you to you all for being here today, be it in person or online. Thank you very much to the research team who worked on the scientific expertise. This was an investment in terms of time and workload. We are so happy to see the conclusion of this work today. Thank you to the interpreters, the technical teams, the people who did the catering, everyone who made the organization of today possible. Thank you again for everything. Once more. Well, please just go to the lunch cocktail. And same place as yesterday, yeah? Same place as the lunch break this morning. Thank you. Thank you to you all. And obviously, thank you from the interpreters. Have a great lunch.